Have you ever wondered what really happens when you touch something hot, or why your heart beats without you thinking about it? Tonight, we're diving deep into the hidden electrical web that keeps you alive, the quiet system of signals, cells, and circuits that makes you, you. Welcome to The Sleepy Scientist. If you're listening tonight, I hope you're somewhere peaceful, maybe tucked under a blanket, lights dimmed, ready to let curiosity and calm take over. These quiet explorations are made to be listened to before sleep, so there's no rush, no pressure to stay fully awake. Just soft science for a gentle mind. If you're new here, I'd love to know where you're watching from. It always amazes me how far these quiet journeys travel, from living rooms and bedrooms to sleepy corners of the world I've never seen. If you enjoy these slow explorations of science, please do tap the like button and subscribe to the channel. And if you're already part of this calm little community, thank you. Truly, your support helps keep these videos floating through the digital night. If you'd like to know when the next one drifts into view, you can click the notification bell. That way, you won't miss the next quiet adventure. And I'll do my best to make sure this one isn't too interesting. But if it does keep you awake, at least you'll drift off knowing exactly how your neurons managed it. So, let's begin. What exactly is this hidden network that lets you move, feel, dream, and remember? And how does it manage to keep working, even as you sleep? The human body is a world within itself, a living galaxy of cells, each one performing its part without question or pause. Among them, one network stands apart. It doesn't pump, digest, or build. It listens, interprets, and commands. It is the whispering current that connects every sensation to every thought. The nervous system, every blink of an eye, every thought that rises uninvited, every heartbeat and breath. All are guided by quiet patterns of electricity, moving faster than any word you could speak. The nervous system is both the body's command center and its messenger, a loop of infinite communication that began before you were born and will continue until your very last moment. Imagine it, countless threads of light running beneath your skin, carrying messages from your fingertips to your brain, from your heart to your thoughts, from the outside world to the inside self. Most of it happens without your awareness. You don't think about blinking. You don't consciously order your stomach to digest. You simply exist, and the nervous system does the rest. Tonight we'll follow those threads. We'll see how they begin as microscopic cells, how they send their messages through chemical whispers and electric sparks, and how together they create motion, sensation, emotion, and memory. It's a story of precision and poetry, of machinery so intricate that it becomes something close to magic. And yet this story isn't just about anatomy, it's about awareness itself. The nervous system doesn't only make your body move, it lets you feel the world. It creates the experience of being alive. So settle in, breathe slowly, and let your thoughts soften. As we move through this quiet circuitry of life, you might just begin to see yourself, not as a collection of organs and bones, but as a living constellation of light. If you were to look inside the human body, not with the eyes of flesh, but with imagination, you would see a city of astonishing complexity. Every heartbeat, every breath, every movement is part of its rhythm. Millions upon millions of tiny inhabitants, the cells, go about their daily work. Some carry oxygen, some build tissue, some fight invaders. But among all these citizens, one group stands apart. They don't build or transport or defend. They communicate. They coordinate. They form the body's greatest network, the nervous system. It is the quiet command center and messenger service of your entire being. Every second, it senses the world, interprets what it finds, and decides how to respond. It is the reason you pull your hand away from a hot pan before you even realize it's burning, the reason your heart speeds up when you're startled, and the reason you can hear these words, understand them, and perhaps feel a little calmer because of them. At its core, the nervous system is made of two great divisions. The central nervous system sits protected within bone, the brain and spinal cord, the headquarters of all thought and decision. The peripheral nervous system is everything that branches outward from it, the endless network of nerves reaching through limbs, organs, and skin, carrying messages to and from the central core. Together, they are like the heart and arteries of information, pulsing continuously, moment by moment, through every corner of the body. You might think of the brain as the capital city, a place of constant planning and decision-making. Its avenues are dense and bright, full of signals travelling at extraordinary speeds. From this capital, the spinal cord stretches downward like a grand highway, strong and well guarded, running through the central column of the body. Off this main route, countless smaller roads branch outward, the nerves, winding through every organ and muscle like narrow side streets and hidden alleyways. Every one of them leads somewhere meaningful. Everyone carries news to or from the capital. When your foot steps on something sharp, the message shoots up these roads, carried by specialized nerve cells. It races through the spinal cord and reaches the brain, which instantly identifies pain, location, and action. Before you can consciously process what's happened, a response is already on its way back down, a command to lift your foot, protect yourself, move away. The entire event takes only a fraction of a second, yet it feels seamless, as if body and mind were one continuous being. But the nervous system is more than a network of wires. It's not a cold or mechanical circuit. It's warm, alive, and fluid. A living system of energy and chemistry that gives rise to feeling and thought. Electricity hums through it, yes, but that electricity is not machine-like. It's biological, gentle, and astonishingly precise. A signal travels not as metal current, but as shifting ions in fluid, as delicate as a heartbeat, as personal as emotion itself. Even when you sleep, this network hums quietly on. It monitors breathing, adjusts your heartbeat, and filters sounds from the outside world. It keeps your balance while you dream, keeps your lungs rising and falling, and even helps the brain clean itself of the day's chemical clutter. If it ever truly shut off, so would you. It senses, it processes, it reacts, it regulates. It's an endless cycle, so natural and automatic that we rarely think about it at all. The nervous system handles both the chaos of sudden action and the serenity of stillness. It's behind every laugh, every shiver, every memory, and every quiet moment of reflection. It is, in every sense, the language of the body made visible through motion. And although it's made of unfathomable complexity, billions of neurons and trillions of connections, it works so effortlessly that it feels simple. You blink, breathe, and swallow without needing to issue a single conscious command. Beneath that apparent ease, a symphony of cells performs perfectly timed exchanges, sending signals faster than any fiber optic cable could dream of. And unlike your Wi-Fi, this network rarely loses connection. It's easy to imagine ourselves as passengers in our own bodies, as though some unseen pilot handles all the controls, but in truth, The nervous system is the pilot. It is not something separate that you own. It is you. Every choice, every feeling, every impulse begins there, in the conversation between brain, spinal cord and nerve. It links your outer world to your inner one. The cool texture of water, the warmth of sunlight, the ache of hunger, the comfort of familiar music, all are signals translated and interpreted through this living web. The world around you doesn't truly exist inside your mind until your nervous system decides what to tell you about it. That means that every experience you've ever had, every taste, every sound, every heartbeat, has travelled through this network. It is the ultimate storyteller, the translator of existence itself. Within its signals lies everything you know about being alive. If you could see it glowing from within, you'd see threads of light weaving through every part of you, shimmering softly even in rest. It's a network that never stops listening, never stops guiding, never stops keeping time. And in its quiet constancy lies the deepest kind of life, one that hums on faithfully, even when the conscious mind fades into sleep. Deep within the vast landscape of the body's nervous system lives a single, extraordinary kind of cell, the neuron. It's small, delicate, and unassuming under a microscope, yet it is the foundation of everything that thinks, feels, and moves. If the nervous system is a city, the neurons are its citizens, not merely living, but constantly communicating, exchanging information in a dance of light and chemistry that never truly stops. A neuron doesn't look like most other cells. It isn't round or simple, but elegantly branching like a tree in miniature. Its short, tangled arms, the dendrites, reach outward like roots, catching incoming signals from neighbouring cells. At the centre sits the soma, the main body of the cell, where the nucleus quietly manages the essentials of life, energy, repair, and order. From that central hub stretches one long, slender fibre called the axon, sometimes reaching distances far greater than the cell itself, extending like a single branch reaching through the forest to touch another tree. The neuron's shape tells its story. It exists to connect. Unlike most cells which focus on keeping themselves alive, a neuron's main purpose is to send messages. It is both messenger and message, both wire and signal. It listens through its dendrites, speaks through its axon, and relies on the delicate chemistry of its membrane to translate life into movement, thought, and memory. Inside this microscopic architecture, something remarkable happens. A neuron maintains a fragile balance of charged particles called ions across its outer membrane. These ions, mostly sodium and potassium, create a faint electrical tension, like the quiet hum of energy waiting to be released. When a neuron receives enough stimulation from its neighbours, that tension shifts. A small gate opens, ions rush across the membrane, and a tiny electrical wave begins to travel down the axon. This is the neuron firing, though it's less like a gunshot and more like a gentle ripple spreading across water. It's called an action potential, a moment when electricity flows, not through wires but through living tissue. That pulse of energy is what allows your fingers to move, your eyes to blink, your memories to resurface, and your heart to keep its rhythm. Each pulse is a thought in motion, a fleeting spark racing through a quiet forest of cells. The axon is wrapped in a special insulating layer made of fatty material called myelin. It works like the rubber coating around an electrical wire, keeping the current from leaking out and speeding the signal's journey. In some neurons, the signal can travel at over 200 miles per hour, fast enough for you to catch a falling object or dodge something before it hits you. The entire process from spark to response happens in less than the blink of an eye. Once the pulse reaches the end of the axon, it faces a tiny gap, the synapse. The neuron cannot cross it directly, so it releases chemical messengers that carry the signal to the next cell, and then, like a relay race, the process begins again. Receive, decide, send. This rhythm never pauses. Even in deep sleep, neurons are murmuring to one another, maintaining the vital hum of life. But not all neurons are the same. There are sensory neurons that bring in information from the outside world. The coolness of air, the warmth of sunlight, the sting of cold water. There are motor neurons that carry instructions outward, telling muscles when to move. And there are interneurons which live in the spaces between, forming vast internal networks of communication, processing information, and deciding what happens next. Each type of neuron is like a different musician in an enormous orchestra, playing its part in the grand symphony of thought and motion. The scale of it all is staggering. In the human brain alone, there are thought to be around 86 billion neurons. Each one connects to thousands of others through branching networks, forming a web of nearly incomprehensible complexity. Trillions of connections, every one of them alive with possibility. When you remember a face, solve a problem, or simply take a deep breath, thousands of circuits ignite and quiet again in perfect coordination. You could spend a lifetime trying to count them and never get close. And yet, for all their complexity, neurons aren't loud or chaotic. Their world is made of whispers, electrical flickers, and chemical messages so subtle that we only recently learned how to detect them. If neurons could talk, they'd never stop. Thankfully, they whisper in electricity instead, their silent language faster and more graceful than any spoken word. It's a form of communication that relies on precision. A neuron can either send a signal or stay silent. There's no halfway point. This simple yes or no system, repeated billions of times per second, becomes the language of everything you are. From the rhythmic beating of the heart to the abstract complexity of imagination, every action and emotion emerges from these binary pulses. Out of such simplicity comes extraordinary diversity. Even though each neuron follows the same basic pattern, none are identical. Some are microscopic, others stretch the length of your leg. Some handle simple reflexes, others help form the complex patterns that allow for language and creativity. Together, they form layered networks where information flows like a stream, sometimes direct, sometimes winding through countless detours, depending on what needs to be done. Imagine for a moment if we could see them at work, a storm of light shimmering beneath the surface of your thoughts, bursts of illumination sparking and fading in patterns of impossible beauty. It would look less like machinery and more like weather, a living aurora made of energy and chemistry. This is the hidden landscape of your mind, and it all begins with the humble neuron. They are resilient yet fragile, ancient in design but endlessly adaptable. They make up not just the brain but the nerves throughout your entire body, ensuring that every movement and sensation is woven into a single tapestry of experience. They are the reason you can feel the world, remember the past, imagine the future, and understand that you are alive right now. It's strange to think that all of this depends on tiny cells that can't be seen without a microscope. They're small enough to fit by the thousands on the head of a pin, yet together they form the vast glowing network that defines human life. They don't look particularly grand, no colours, no sounds, no fireworks, just thin threads and quiet pulses. But if you could somehow listen closely enough, perhaps you would hear them. A chorus of soft electrical whispers, a symphony played in silence, performing the ceaseless rhythm of thought itself. At the heart of every thought, every movement and every fleeting emotion lies a tiny space, a gap so small that it cannot be seen even with most microscopes. This is the synapse, the narrow divide between two neurons. It's the place where messages leap from one cell to the next, where electricity becomes chemistry, and where the magic of communication truly happens. When a neuron fires, its electrical wave travels down the axon until it reaches the very tip, a region called the axon terminal. But the signal can't simply continue forward. There's a gap ahead, a sliver of empty space only a few millionths of a millimetre wide. Electricity cannot cross it directly, so the neuron switches languages. It turns its electrical impulse into a chemical message. Tiny sacs at the end of the neuron open, releasing molecules called neurotransmitters into the space between each molecule, drifts gently across that microscopic divide and binds to the next neuron, delivering its message with exquisite precision. It's a breathtakingly delicate process, one that happens trillions of times every second throughout your body. Imagine it as a vast ocean of communication where every droplet carries meaning. Each neurotransmitter is a message in a bottle, drifting across an invisible sea from one shore of consciousness to the other. Some bottles carry instructions to act, others carry feelings, and some simply whisper that all is well. There are many types of neurotransmitters, each with its own subtle tone. Serotonin, for instance, is often associated with mood and calm. When serotonin levels are balanced, the mind feels steady, content, and at ease. Too little, and the world can seem sharper, more anxious, as though a gentle filter has been removed. Dopamine, by contrast, is the spark of reward and motivation, the chemical that tells the brain, "That was good, do it again." It's why you feel satisfaction after solving a problem or enjoying a delicious meal. Then there's acetylcholine, a tireless messenger of movement and attention, responsible for focus, coordination, and the simple grace of catching something mid-air before it falls. Each of these chemicals has its own rhythm, its own poetry. They work not in isolation but together, layering emotion, motion, and awareness into the experience of being human. Without them, the electrical pulses of the neurons would be meaningless static, pure energy without interpretation. Neurotransmitters give that energy context. They translate spark into sensation, voltage into value. If you could watch this process unfold, it would look almost like weather inside the brain, a constant flicker of light and colour, tiny clouds of chemistry forming and dissolving in endless patterns. The electrical storm of the neuron ends in the softest rain of molecules, and from that rain new signals bloom. One neuron excites another, or quiets it, or sends a subtle suggestion that lingers in the background. It's a world of conversation, unending and unseen. A neuron's version of small talk is literally electrical. Every flicker and pulse is part of a dialogue that spans the body from head to toe. The neurons chat about temperature, balance, hunger, memory, and imagination, all at once, all the time. And somehow, from this constant chatter emerges something coherent, a feeling, a thought, a moment of recognition. What makes the synapse so astonishing is not just how it works, but what it allows. This tiny gap is where experience becomes change. Every time a signal crosses it, the connection between these two neurons can grow stronger or weaker. The more often a pathway is used, the more efficient it becomes, like a well-trodden path through a forest. If you learn to play an instrument, recall a scent from childhood, or feel comfort in a familiar face, it's because certain synapses have strengthened their hold. This adaptability, the ability to reinforce or fade connections, is what makes memory and learning possible. It's what allows a child's brain to absorb languages effortlessly, and an adult's brain to recover from injury or learn a new skill. The synapse is not just a bridge for signals, it's the sculptor of identity, shaping how information flows through your neural landscape. It's also deeply personal. No two people have the same pattern of synaptic connections. Even identical twins, born with the same DNA, develop unique neural maps as they live and experience the world differently. Every emotion, every sound, every moment of laughter or pain leaves its trace in this network of connections. Over time, your brain becomes the physical record of your life, an ever-evolving portrait drawn in electricity and chemistry. You could say that individuality begins here, in these microscopic spaces. Every preference, memory, and habit is written not in words or symbols, but in the strength and timing of these tiny chemical exchanges. When you remember a song, feel nostalgia, or experience joy, what you're really sensing is the choreography of millions of neurons and billions of synapses working together, replaying the pattern of a moment once lived. And though we understand much about how it works, the sheer scale of it defies comprehension. There are estimated to be around 100 trillion synapses in the human brain, more connections than stars in the Milky Way. Each one flickers on and off, not at random but in harmony, composing the grand pattern that is consciousness. It's humbling to think that the essence of who you are, your hopes, fears, and memories, depends on countless microscopic bridges passing tiny molecules back and forth. But in the humility lies beauty. The synapse shows us that even the smallest spaces can hold entire worlds, that communication can be both physical and poetic, that the spark of thought can travel through something no wider than a beam of light. Every moment of understanding, every flash of inspiration, every quiet feeling of peace starts in that near invisible gap. It's the breath between one signal and the next, the pause that allows meaning to form. From these gaps come thoughts, feelings, choices, and dreams, all the quiet whispers that make you human. Inside the shelter of the skull lies a universe unlike any other, a landscape so intricate that no map could ever truly capture it. The brain is a world folded in on itself, a galaxy of soft ridges and valleys, each one alive with electrical storms too small to see, but powerful enough to define a life. At first glance it seems mysterious, even chaotic, yet within its folds lies extraordinary order. This is the command center of existence, the organ that interprets the world, creates dreams, stores memories, and invents every thought that has ever passed through a human mind. The brain is often compared to a wrinkled walnut, but that does it a great injustice. Its folds are not random. They are the result of evolution's ingenuity, a way to fit immense processing power into a compact space. Each ridge, or gyrus, increases surface area, allowing more neurons to fit within the limited space of the skull. If you could somehow unfold the surface of your brain, it would cover an area roughly the size of a large pillowcase. Yet it all folds neatly inside, quietly humming with life. The largest part of this landscape is the cerebrum, the vast outer region where thought, memory, language, and imagination reside. It's what allows you to reason, to plan, to create art, or recall a song from childhood. The cerebrum is divided into two halves, the left and right hemispheres, each responsible for different, though often overlapping, functions. The left side is generally more analytical, more attuned to language, logic, and detail. The right side is often associated with intuition, emotion, and creative thought. But these are not opposing forces. They are partners, two sides in quiet dialogue, joined by a silver thread of understanding, the corpus callosum, a bridge of millions of nerve fibers that keeps their conversation flowing every moment of your life. Below the cerebrum lies a smaller but crucial structure, the cerebellum. Though it makes up only about 10% of the brain's volume, it holds more than half of its neurons. The cerebellum is the silent craftsman of coordination and precision. It keeps you upright when you walk, guides your hand when you write, and lets a pianist's fingers find their way across the keys without conscious thought. It refines every movement, smoothing away the rough edges of motion until action becomes art. Even when you think you're perfectly still, the cerebellum is quietly balancing you, adjusting the micro movements that keep you from toppling over. Deeper still sits the brain stem, the oldest and most essential part of the brain. It's small, almost humble in appearance, but it carries out the most vital tasks of all. The brainstem keeps you breathing, your heart beating, and your eyes blinking. It regulates sleep and wakefulness, maintains body temperature, and coordinates the rhythms of life that continue even when you're completely unaware. If the cerebrum is thought and the cerebellum is grace, then the brainstem is survival itself, the ancient engine that never stops running. Together, these three regions form a hierarchy of complexity and control. The brainstem manages the automatic, the cerebellum refines movement, and the cerebrum creates awareness. But there is no strict boundary between them. They communicate constantly, sharing information in real time to create the illusion of a single, seamless experience. You don't consciously think about maintaining balance while walking or adjusting your breathing as you speak. These systems coordinate so naturally that it all feels effortless. The cerebrum itself is divided further into lobes, each with its own quiet specialty. The frontal lobes sit just behind your forehead, the architects of decision-making, planning, and self-control. The parietal lobes just behind them handle sensations, the map of touch, temperature, and space. The temporal lobes, located near the ears, process sound and help form memories, while the occipital lobes at the back of the head translate patterns of light into sight. Each lobe works independently, yet none can function in isolation. They are like neighborhoods in a vast city, each with its own culture and purpose, but all connected by the same power grid of thought. Within this city there are special districts of activity. The sensory cortex running across the top of the brain receives incoming information from the senses. Every touch, sound, or smell enters here before being passed along for interpretation. The motor cortex just next to it sends out commands telling the muscles how to move, and between them lies a great network of association areas, regions that don't deal with raw data but with meaning. They connect sensation with experience, turning sound into music, color into beauty, and words into language. If the brain were an orchestra, the sensory cortex would bring in the instruments, the motor cortex would conduct the movements, and the association areas would compose the music. Yet somehow, This orchestra plays without a conductor. There is no single part of the brain in charge of everything. Coordination emerges naturally from the cooperation of billions of neurons. Each one fires in time, responding to its neighbours in patterns of rhythm and resonance that give rise to thought, memory, and imagination. Despite centuries of study, much of this coordination remains a mystery. How does a single brain synchronize billions of separate activities with such grace and precision? There's no central control room, no operator at a switchboard. And yet, every second, the brain manages millions of simultaneous operations, processing sensory information, maintaining balance, planning motion, recalling memory, and even imagining things that do not yet exist. Within this harmony lies the beauty of complexity. The brain is not a machine with moving parts that wear down or need oiling. It's a living network, constantly rebuilding, rewiring, and refining itself. New connections form every moment. Old ones fade as they are no longer needed. This plasticity, the ability to change, is what allows the brain to learn and adapt throughout a lifetime. It's humbling to realize that this soft, folded mass of tissue, weighing about 3 pounds, is responsible for every poem, every invention, every piece of music humanity has ever created. It holds within it the memory of every person you've loved, every place you've been, and every thought you've ever had. All of it exists within those folds, encoded not in words or symbols, but in the firing patterns of neurons and the strength of their connections. If you were to stand outside yourself and watch your brain at work, it would appear as a shimmering landscape of light, billions of points flickering and fading in perfect coordination. Some areas would glow with activity, others would rest, and all would shift like weather, responding to every change in thought or sensation. It would look chaotic at first, but within that chaos lies exquisite structure, a harmony without a single note out of place. The brain is the ultimate paradox, fragile enough to be bruised by a fall, yet powerful enough to build civilizations. It is both the observer and the observed, both the question and the answer. And though we may never fully understand how its endless networks combine to create the experience of being alive, we can marvel at the wonder of its design. Billions of cells, no conductor, yet perfect harmony, a living symphony of thought quietly playing inside every human head. Running down the center of the body, hidden deep within the protective columns of the spine, lies one of nature's most extraordinary creations, the spinal cord. It is the living highway of communication, a shimmering trunk of nerves connecting the brain above to every organ, muscle, and sensation below. If the brain is the control tower, the spinal cord is the main thoroughfare that carries its instructions outward and brings back constant updates about the world beyond. Without it, the mind would be trapped in silence, unable to move or feel. The spinal cord is about as thick as your little finger and roughly 18 inches long in most adults, but its importance far outweighs its size. It runs through a hollow tunnel formed by the vertebrae, those interlocking bones that make up the spine, and continues all the way from the base of the brain to the lower back. From this glowing central column, nerves branch outward in pairs at regular intervals, like exit ramps from a highway, connecting to every region of the body. These nerves carry both directions of communication, messages descending from the brain to command action, and messages ascending back to the brain to report what's happening. Imagine the spinal cord as a two-way roadway. One lane carries orders downward, move your arm, take a step, draw a breath. The other lane carries sensory information upward, the warmth of the sun, the prick of a thorn, the weight of gravity on your feet. The brain doesn't need to micromanage every detail. It sends broad instructions, and the spinal cord takes care of the delivery. At the same time, it filters the information that flows back, prioritizing what's urgent and what can wait. But the spinal cord is not merely a messenger. It can make decisions of its own, swift and silent ones. If you touch something burning hot, your hand jerks away before you even have time to realize what's happened. That isn't your brain deciding, it's your spinal cord. This is called a reflex, an automatic, lightning-fast response that bypasses conscious thought to protect you from harm. In these moments, the spinal cord acts like a local branch office, handling urgent matters before corporate even gets the memo. Reflexes are essential for survival. They are the body's emergency responses, built for speed rather than deliberation. In a single instant, sensory neurons in your skin detect danger and send a signal into the spinal cord. There, the message takes a shortcut, activating motor neurons that send an immediate command back to the muscles: pull away, move, escape. Only afterward does the information reach the brain, which then interprets what just occurred. This system ensures that reaction happens almost before sensation, an elegant example of how efficiency and instinct coexist within the human body. Beneath this automatic brilliance lies an intricate structure. Inside the spinal cord, nerve fibers are organized into distinct regions, some carrying sensory information upward to the brain, others carrying motor commands downward to the muscles. These pathways are separated but intertwined, like lanes of traffic on a busy road, constantly flowing, never colliding. Between them, networks of interneurons act as tiny communication hubs, redirecting signals where they're needed and ensuring that movement and perception remain perfectly synchronized. Surrounding this delicate structure are several layers of protection. The spinal cord is encased in 3 thin but resilient membranes called the meninges, which wrap around it like layers of silk armor. Between these membranes flows cerebrospinal fluid, a clear, shimmering liquid that acts as both cushion and cleanser. This fluid bathes the spinal cord in constant motion, absorbing shocks and delivering nutrients. You might think of it as a living river that cushions thought, a stream of life that both protects and nourishes the system it surrounds. The vertebrae themselves form the spinal cord's outer fortress. Each bone fits together with the next in a gentle curve, allowing flexibility without compromising strength. Between them lie discs of cartilage that act as shock absorbers, letting you twist, bend, and move with ease while keeping the precious cord safely enclosed. It's a design so effective that even modern engineering struggles to replicate it. Protection, flexibility, and efficiency all in one. Through this protected channel, the spinal cord handles an enormous flow of information. Every time you take a step, signals travel down to your legs, telling muscles to contract in sequence, while other signals rush upward, informing the brain about position and balance. This happens so quickly and smoothly that you never notice. When you decide to run, the spinal cord coordinates dozens of muscles to move together. When you stand still, it manages the subtle corrections that keep you from falling. Even the simplest movement is a complex conversation between brain, spinal cord, and body carried out in milliseconds. The spinal cord also acts as a translator between different kinds of nerves. Sensory nerves bring in information from the skin, eyes, and internal organs, while motor nerves send instructions outward to muscles and glands. In the middle, interneurons interpret and redirect the traffic, ensuring that everything arrives exactly where it's meant to. The precision of this exchange is astonishing. Millions of messages flowing continuously without confusion, each one routed to the right place. And while it often works in silence, the spinal cord has an active partnership with the brain. Some signals require conscious control, like moving a hand to write or choosing to look in a certain direction. Others happen entirely below awareness, like adjusting posture or maintaining muscle tone. The spinal cord handles both seamlessly, shifting between automatic and voluntary actions as though reading the mind's intentions before they're even spoken. When this highway is disrupted, through injury or disease, the effects can be profound, a reminder of just how vital this connection is. Modern medicine has come a long way in understanding the spinal cord, and research into nerve regeneration continues to advance. Still, the resilience of the system itself is remarkable. Even after partial injury, some nerve fibers can reroute and form new connections, finding alternative pathways to restore communication. The body, it seems, is determined to keep talking to itself. It's easy to overlook the spinal cord, hidden as it is behind bone and muscle, but without it, the brain would be a world cut off from its own creation. The spinal cord doesn't just deliver commands, it integrates the body into a single, responsive whole. It's the bridge between thought and action, sensation and awareness. If you could see it in motion, the signals racing down its length, the reflex arcs flashing like fireflies in the dark, you'd recognize it for what it is, a living highway of light, carrying the pulse of life from the mind to the body and back again. And perhaps most remarkable of all is this: the spinal cord proves that the body can think on its own. Long before the brain analyzes, questions, or reflects, the body reacts, protects, and adapts. Intelligence doesn't always need words. Sometimes it exists in the split-second wisdom of movement. The quiet brilliance of the spinal cord doing exactly what it was made to do. Beyond the safety of the skull and spine, the nervous system stretches outward like a great web of living threads, weaving through muscle, bone, and skin. This vast network is called the peripheral nervous system, the extension of the brain into every fingertip, every heartbeat, every breath of motion. It is the reason the body feels unified, not as separate parts, but as a single living whole. If the brain is the capital city and the spinal cord its main highway, then the peripheral nerves are the endless streets and alleyways that lead to every home in the body. They're the invisible messengers carrying news in both directions, sensory information rushing toward the brain and motor commands racing back out to the muscles. Every touch, every blink, every shiver of cold or warmth depends on these tiny fibers working with astonishing precision and speed. These nerves are delicate thread-like structures, some thinner than a strand of hair, yet they carry signals at speeds that would make lightning jealous. When you brush your hand against something soft, sensory receptors beneath your skin translate that contact into electrical impulses. Those impulses shoot through nerve fibers to the spinal cord, up to the brain, where they're interpreted as texture, temperature, or pressure. It happens so fast that your awareness of the sensation feels instant. Sensory nerves are the body's reporters. They tell you where you are in space, what you're touching, whether it's too hot, too cold, too sharp, or just right. They're finely tuned, each specializing in a different type of message. Some respond to pressure, others to vibration, others to changes in temperature. Still others detect damage or danger, the ones responsible for the sensation of pain. They act as early warning systems, keeping you aware of your boundaries with the world. Pain may not feel like a gift, but it is one. It teaches you to pull back, to protect, to heal. Without it, you might not notice injury until it's too late. There are rare people born without pain receptors, and while it sounds ideal, it's perilous. They can break bones or burn skin without realizing it. The body's discomfort is often its wisdom, translated through these tiny nerve endings that never sleep. Running alongside these sensory messengers are the motor nerves, the ones that carry instructions in the opposite direction. These are the doers, the action takers. When you decide to lift your hand, the signal originates in the brain's motor cortex, travels down through the spinal cord, and exits through the peripheral nerves to activate muscle fibers. In less than a blink, the thought has become motion. This two-way system of sensation and control works so smoothly that it feels effortless. When you pick up a cup, nerves in your fingers send back constant updates about pressure and texture. Your brain adjusts grip strength in real time, making sure you don't crush the cup or drop it. It's a conversation, fast, silent, and continuous, between the mind and the world. There's no single moment when it begins or ends. Every gesture is the endpoint of an invisible electrical chain, looping endlessly through the body. You tap your finger on a table, and a cascade of neurons fire in perfect synchrony. You close your eyes, and muscles obey instructions so swiftly that thought and action blur together. You smile, and dozens of small muscles move in unison, each controlled by nerves that have never missed a beat since the day you were born. Within this outer network are some of the body's most specialized cables, the cranial nerves. There are 12 pairs of them, branching directly from the brain instead of the spinal cord, like dedicated lines for the senses. One pair carries the smell of morning coffee to your awareness. Another brings in the shimmer of light and color through your eyes. Others control facial expression, swallowing, balance, and hearing. These nerves are what make the face so expressive. They let you laugh, cry, squint, or smile without conscious thought. The optic nerves deliver the world's colors and shapes to your mind. The auditory nerves turn invisible air vibrations into the music of language and sound. The olfactory nerves, responsible for smell, connect directly to the emotional centers of the brain, which is why scent can so powerfully stir memory. A faint whiff of perfume or the smell of rain on dust can bring back a moment you thought long forgotten, carried across time on these ancient pathways. Together, the peripheral and cranial nerves form a single network, the body's living internet. Information flows in and out, up and down, across and around, and unlike a man-made network, it never buffers, never crashes, and doesn't need an update. Your nervous system never ghosted your body. It replies to every single message. These nerves also play a quiet role in reflexes and posture. Even as you sit still, countless sensory signals are reporting the position of your muscles and joints. Without your awareness, motor nerves are making tiny adjustments to keep you balanced. The body is in constant communication with itself, a silent symphony of feedback loops that keep you upright, breathing, and aware. When nerves are injured or compressed, the messages they carry can become distorted or lost. A pinched nerve in the neck might send a strange tingling to the fingertips. Damage to the peripheral nerves, known as neuropathy, can dull sensation or create odd, phantom feelings. And yet, the system is surprisingly resilient. Nerves can regrow slowly, rebuilding bridges 1 millimeter at a time. The body's instinct for connection, even at the microscopic level, is remarkably persistent. What's most remarkable is how seamlessly these threads of communication blend into daily life. You don't have to remind yourself to feel, move, or adjust. The peripheral system takes care of it all. The brain gives broad guidance, but it's the nerves in your hands, feet, and skin that handle the details. They translate the physical world into experience, allowing you to live inside it rather than merely observe it. If you could see this network in motion, it would look like a glowing web just beneath the surface of the skin, threads of light pulsing in perfect rhythm, connecting every fingertip and toe to the mind. Each signal, faster than lightning, carries meaning. Every brush of texture, every movement, every breath is an electrical conversation between body and brain. And within that conversation lies the miracle of connection. You're not simply housed within your body, you are your body, a network of awareness reaching in every direction, touching the world through countless invisible threads. The peripheral nervous system ensures that even the smallest gesture, a wave, a blink, a heartbeat, is part of something greater, a living dialogue between you and everything around you. Beneath your conscious awareness, beyond thought or intention, a hidden system works tirelessly to keep you alive. It doesn't ask for permission, and it doesn't wait for instruction. It adjusts your heartbeat, controls your breathing, regulates your digestion, and fine-tunes your temperature. This quiet network is called the autonomic nervous system, the part of you that never sleeps, never stops, and never complains. While the conscious mind worries about tomorrow, the autonomic system is focused entirely on the present. Its purpose is simple, yet profound: to keep the body in balance, to adapt instantly to whatever life throws your way. It does this through two remarkable divisions, perfectly opposed and yet beautifully in harmony: the sympathetic and parasympathetic systems. The sympathetic system is your internal alarm, the quick-thinking guardian that prepares you for action. It's often described as the fight-or-flight response, though that phrase hardly captures its sophistication. When a threat appears, a loud noise, a flash of danger, or even a stressful thought, this system surges into motion. The heart begins to race, pumping blood to the muscles, the pupils widen to take in more light. The airways open, drawing in oxygen for quick energy. Even digestion slows, because right now survival takes priority over lunch. It's not a panic, it's a performance. Every part of the body shifts gears in an instant, coordinated perfectly without a single conscious thought. Adrenaline is released, heightening awareness and sharpening reflexes. Muscles tense, ready for movement. Blood pressure rises just enough to deliver oxygen where it's needed most. All this happens automatically, faster than any deliberate decision could. It's the body's ancient way of saying, "I've got this. Just hold on." But no dancer can stay on their toes forever. As the sympathetic system finishes its turn, its partner steps gracefully forward. The parasympathetic system, often called rest and digest, where one creates tension, the other brings release. It slows the heart rate, softens the breath, restarts digestion, and restores calm to the body's rhythm. It is the sigh after the storm, the gentle hand that tells every organ, "You can relax now." The two systems move together in an endless duet, one preparing for challenge, the other guiding you back to peace. You could imagine them as dancers sharing the same stage, taking turns to lead, their movements balanced and fluid. When life demands alertness, the sympathetic takes the spotlight. When safety returns, the parasympathetic glides in, ensuring you don't stay wound up forever. This choreography plays out every day, from waking to sleeping, from excitement to serenity. Your heartbeat follows their rhythm. In moments of fear or anticipation, it races. In moments of calm, it slows. Breathing mirrors the same pattern, rapid and shallow when tense, deep and steady when relaxed. Even the pupils in your eyes respond, widening to seek light in urgency, shrinking again when peace settles in. The stomach and intestines follow suit. Digestion pauses during stress and resumes once tranquility returns. What's remarkable is how seamlessly this balance is maintained. The autonomic system operates through feedback, a constant conversation between sensors scattered throughout the body and the brain's control centers. If blood pressure rises too high, signals travel back to lower it. If oxygen levels drop, breathing adjusts. This continuous self-regulation is called homeostasis, and it's one of biology's quiet miracles. Without it, the body would swing wildly between extremes. With it, we glide through life's fluctuations with remarkable stability. The precision of this balance is astonishing. Your body temperature stays nearly constant despite changes in weather. Your blood maintains the right levels of sugar, salt, and acidity. Hormones ebb and flow in cycles too intricate to notice. And all of this happens beneath the surface. No dashboard, no alarms, no need for conscious control. It is as if you are piloting a ship that steers itself, adjusting sails and course against invisible winds. The brain region most responsible for this balancing act is the hypothalamus, a small but mighty structure nestled deep within the brain. It receives constant updates from sensors throughout the body and makes real-time adjustments. When you sweat on a hot day or shiver in the cold, it's the hypothalamus orchestrating the response, keeping everything in harmony. It acts so quietly that you almost never feel it, unless it stops working, in which case balance quickly gives way to chaos. Every moment of your life, these two branches of the autonomic system weave together to keep you stable, switching roles seamlessly. When you stand up quickly, they stop your blood pressure from plummeting. When you eat, they reroute energy to digestion. When you drift into sleep, they lower your heart rate and relax your muscles. Even dreams unfold under their gentle supervision. Of course, in the modern world, the sympathetic system often finds itself overworked. Ancient instincts still respond to modern stress, deadlines, noise, bright screens, as if they were threats. The result is that the body can sometimes stay stuck in a state of alertness, the dancer of tension unable to step aside. Deep breathing, meditation, and rest are ways of inviting the parasympathetic system back onto the stage, reminding the body that it is safe to slow down. It's comforting to know that balance is built into us, that the nervous system is constantly seeking stability no matter what happens. This system juggles heart rate, temperature, hormones, and blood flow with perfect timing, and it never drops the ball. Your nervous system juggles your organs so you don't have to, and it's a good thing too, because conscious multitasking of that sort would end badly. Every moment of your life is shaped by this delicate dance of tension and release. Without the sympathetic system, there would be no drive, no readiness, no spark to move. Without the parasympathetic, there would be no peace, no digestion, no recovery. Together they form the pulse of balance, the push and pull that keeps life steady through both chaos and calm. Even now, as you listen to these words, the two systems are quietly at work. Your lungs expand and contract, your heart keeps time, and your body adjusts itself to comfort. You don't have to think about it, or even notice it. It happens because somewhere deep inside, your nervous system is still dancing, graceful, invisible, and endlessly patient, keeping you alive with every step. The world around you may seem solid, continuous, and immediate, a seamless stream of colour, sound, texture, and scent. But in truth, you never experience the world directly. What you see, hear, taste, touch, and smell are not the world itself but messages, carefully translated by your nervous system, then interpreted by your brain. Every moment of awareness is a masterpiece of reconstruction, built entirely from electrical signals. Your senses are the body's gateways, the instruments of its grand orchestra. They turn the chaos of energy around you into something meaningful, transforming vibrations, chemicals, and pressure into sensations that form the stage on which your life unfolds. You live inside this symphony, but the performance is internal, conducted by neurons and shaped by interpretation. Let's begin with sight, the most dominant of the senses for most people. Vision starts not in the eyes, but in light. Streams of photons travelling from distant objects and striking the retina, the thin sheet of cells at the back of the eyeball. Their specialized receptors called rods and cones translate those photons into tiny electrical impulses. Rods handle shades of darkness and light, while cones pick up color, red, green, and blue, from which every hue of the visible world can be mixed. The signals travel through the optic nerve toward the brain, where they're sorted, analyzed, and combined into the coherent image you believe you see before you. Yet what you see is not the raw light itself, but the brain's best guess at what that light means. It fills in blind spots, corrects colours in shadow, and straightens the distortions of perspective. The world as you perceive it is an edited production, not a live feed. You do not see the world as it is, but as your neurons tell you it might be. Hearing works in much the same way, converting energy into perception through delicate machinery. Sound waves travel through the air and enter the ear canal, causing the eardrum to vibrate. These vibrations are amplified by the tiny bones of the middle ear, the smallest bones in the body, and passed on to the cochlea, a spiraled, fluid-filled structure in the inner ear. Inside the cochlea are thousands of microscopic hair cells that sway like reeds in the wind. Each hair cell responds to a particular frequency, translating vibration into an electrical signal that travels to the brain's auditory cortex. From this symphony of electrical impulses, the mind constructs the experience of sound, the richness of music, the tone of a friend's voice, the rhythm of rain. Silence itself is not an absence of sound, but the moment when those cells stand still, waiting for the next wave to arrive. The world hums with energy, and your ears translate that hum into meaning. Touch, the oldest and most fundamental sense, keeps you grounded in reality. Beneath your skin are countless sensory receptors, each tuned to a different form of contact, pressure, temperature, texture, vibration, or pain. When you press your hand against a surface, these receptors convert mechanical force into electrical signals, carried through the nerves to the spinal cord and up to the brain. The brain then paints a map of the sensation, warmth or coolness, rough or smooth, soft or sharp. Touch is not confined to the hands, it covers you entirely, a living sensor that surrounds your body, always alert to danger and comfort alike. It's how you know where your body ends and the world begins. Yet even this boundary is flexible. The brain constantly updates its sense of where you are, which is why a prosthetic limb can, with time, begin to feel like part of the self. Taste and smell are the twin senses of chemistry, detecting the molecular signatures of the world. On your tongue, clusters of taste buds identify 5 main sensations: sweet, salty, sour, bitter, and umami. The deep savouriness found in foods like mushrooms and broth. Each taste is a signal, a message about nutrition and safety. Sweetness suggests energy, bitterness warns of poison, and salt signals balance. Smell, meanwhile, bypasses the usual relay stations and connects directly to the emotional centres of the brain. Airborne molecules drift into the nasal cavity and bind to receptors that send messages to the olfactory bulb. From there, the information travels straight into areas linked to memory and emotion. That's why scent has such a powerful hold on experience. A single whiff can unlock a flood of feeling. The faint smell of old books, the sharpness of citrus, or the smoke of a distant fire can pull you instantly back through time, into moments you thought were long forgotten. Beyond these classical 5 senses lie others, quieter but just as essential. Balance, for instance, comes from the vestibular system in your inner ear, a set of fluid-filled canals that detect motion and gravity. When you spin too quickly and feel dizzy, it's because the fluid inside those canals is still moving, telling your brain the world is spinning even after you've stopped. Then there's proprioception, the body's sense of its own position. Even with your eyes closed, you can touch your nose or walk across a room, because proprioceptive nerves constantly report where each limb is in space. Together, these senses form a unified field of awareness. The brain doesn't treat them as separate channels, but weaves them together into a single, seamless experience. A glowing sunset is not just light on the retina, it's warmth on your skin, the sound of distant waves, the scent of salt in the air, and the gentle taste of wind on your lips. The nervous system synchronizes all of this, creating the illusion that you inhabit a stable, consistent world. But that world exists only in the brain's interpretation. It fills in gaps, smooths over noise, and constantly predicts what will happen next. Most of what you perceive isn't what your senses deliver, but what your brain expects to find. When it's right, you feel stable and certain. When it's wrong, illusions appear. A shadow mistaken for a figure, a sound heard in silence, a sensation that lingers after it's gone. This act of interpretation is not a flaw, it's a triumph of efficiency. The brain takes incomplete, ambiguous data and turns it into a reality rich enough to navigate and enjoy. Every colour, every melody, every heartbeat you feel is the end result of this constant translation. The nervous system doesn't show you the world, it lets you experience its possibilities. It's remarkable to think that the same electrical language used to move your muscles and keep your heart beating is also what gives rise to the shimmer of sunlight, the sweetness of fruit, and the rhythm of music. Out of raw energy and chemistry, the nervous system creates sensation, and from sensation, consciousness itself. In that sense, perception is both art and science. The mind is not just a receiver of reality, but its artist, blending light, sound, and touch into something coherent and deeply personal. You are both observer and creator, translating physics into poetry with every moment you live. And perhaps that's the quiet wonder of it all, that from simple electrical signals travelling through cells, the universe becomes visible, audible, and tangible. The nervous system is not just how you sense the world. It is the world, filtered through your own unique composition. The mind, in its endless creativity, is both the artist and the observer, forever painting reality from within. Every movement you make begins long before a single muscle contracts. It starts as a spark, a quiet intention in the mind, a whisper of thought that says, "I'll reach for that," or "I'll walk there." That whisper travels through the nervous system, igniting a chain reaction so smooth and instantaneous that you rarely notice it's happening. From thought to motion, the transformation feels effortless, yet behind it lies a breathtaking symphony of coordination. The command for movement begins in the brain's motor cortex, a strip of tissue running across the top of the head like a headband made of electricity. Here, neurons fire in precise patterns depending on what you plan to do. One pattern for lifting a cup, another for smiling, another for running. Each area of the motor cortex corresponds to a specific region of the body, mapped like a distorted figure known as the motor homunculus. The hands and face occupy large portions of this map because they require extraordinary precision, while broader movements of the legs and torso take less neural real estate. Once the plan is formed, the signal travels downward through the spinal cord, racing along motor neurons toward its destination. The impulse reaches the correct muscle fibers, and they contract in sequence, creating motion. Every step, gesture, or stretch begins this way, an invisible current flowing from the brain to the body. And though it happens in an instant, it involves thousands of neurons working together with perfect timing. But movement is rarely the work of the motor cortex alone. The cerebellum, tucked neatly at the back of the brain, acts as the coordinator and quality controller of motion. It fine-tunes the signal, smoothing rough edges and adjusting for balance and timing. If the motor cortex is the composer of the music, the cerebellum is the conductor, ensuring the rhythm stays true. Without its steady guidance, even simple movements would become clumsy and unpredictable. Then there's the spinal cord, serving as both highway and translator. It ensures that the messages from the brain reach the right muscles while sending constant feedback in return. It also handles reflexes and balance adjustments automatically, freeing the brain from micromanaging the details. When you walk, for example, the spinal cord keeps your steps rhythmic and coordinated, while the brain focuses on where you're going, not how you're getting there. Movement is never one-directional. As the brain sends commands outward, sensory nerves send updates back. This constant feedback loop allows for astonishing precision. When you reach for a glass of water, your fingers don't just grab, they adjust. Sensory receptors in the skin report on pressure and texture, while stretch receptors in the muscles inform the brain about position and tension. The brain instantly modifies the strength of the grip, making it firm enough to hold but gentle enough not to crush. It all happens faster than conscious thought, a real-time dialogue between neurons, muscles, and senses. Each movement is a silent conversation between brain and body, an elegant call and response that turns intent into action. Not all movements are created equal. Some demand power and force, the swing of a hammer, the kick of a ball, while others require grace and delicacy. Scientists call these gross and fine motor skills. Gross motor control governs large, sweeping actions, engaging groups of muscles that move the body as a whole. Fine motor control, on the other hand, is the art of subtlety, threading a needle, typing a sentence, playing an instrument. Is what allows a painter to blend colours with precision, or a surgeon to perform delicate operations with steady hands. The difference between lifting a feather and throwing a stone lies in the degree of coordination between these systems. The same motor pathways are at play, but the brain recruits different amounts of force and precision for each task. The cerebellum and sensory feedback systems work tirelessly in the background, adjusting muscle contractions down to fractions of a second. Without their constant corrections, even simple movements would wobble like a poorly balanced wheel. Everyday gestures you take for granted rely on this intricate control. Walking requires a synchronized ballet of muscle contractions, balance corrections, and joint adjustments, and that's before you add stairs, uneven ground, or a full cup of coffee to the mix. Standing still is, in fact, an act of constant movement. Your muscles make hundreds of tiny corrections each second to keep you upright. Even scratching your nose is a full neurological event, a microsecond negotiation between decision, precision, and feedback that results in perfect aim every time. One of the most remarkable features of movement is how the brain learns to make it automatic. At first, new motions are clumsy, demanding full attention. Think of learning to ride a bike or play a musical instrument. Each attempt sends a flood of feedback through the system, and the brain adjusts its firing patterns accordingly. With practice, those patterns become smoother, faster, and more efficient. The cerebellum and motor cortex store the sequence, and soon the movement becomes second nature. You no longer think about balancing or fingering chords. The body remembers for you. This process, called motor learning, relies on plasticity, the ability of neurons to form new connections. Each repetition strengthens the communication between brain and muscle, carving out a neural shortcut. Over time, the nervous system refines not just physical movement, but the timing of movement, creating the effortless fluidity we call skill. Interestingly, the brain rehearses motion even when the body is still. Athletes and dancers often visualize their movements before performing, and studies show that this mental practice activates many of the same neural circuits as the real thing. The brain, it seems, cannot always tell the difference between doing and imagining. In a sense, every movement exists twice, first as thought, then as reality. Balance plays a crucial role in this delicate dance. As you move, sensors in your inner ear, eyes, muscles, and joints constantly inform the brain about position and motion. These signals integrate seamlessly, allowing you to adjust posture, coordinate limbs, and recover from a stumble before you even know you're off balance. It's this web of feedback and adjustment that lets you run, jump, or dance without having to consciously plan every step. The precision of this system is astonishing. In just 1 second, your brain can send thousands of signals to dozens of muscles, each contracting and relaxing in perfect harmony. You can reach for a falling object, tie your shoes, or catch yourself from slipping on ice, all without conscious planning. The nervous system orchestrates these actions like an experienced conductor, uniting strength, balance, and grace into one seamless performance. Even rest involves movement on a smaller scale. The eyes dart beneath closed lids during dreams, the chest rises and falls, fingers twitch faintly. The nervous system never truly stops moving, it simply changes tempo. This constant readiness, this poised responsiveness, is part of what makes life feel alive. It's humbling to realize how much of your daily existence depends on this silent choreography. Every gesture, every step, every smile is the result of countless electrical messages racing through nerves and circuits, checking, correcting, and adjusting in perfect synchrony. Movement is not just a function of the body, it's a language, a dialogue between mind and matter. And within that dialogue lies something beautiful. A thought becomes motion, an idea becomes action, the intangible becomes visible. Each movement, from the smallest flicker of a finger to the grandest leap, is proof that thought can shape the physical world, that the mind and body, though distinct, move always as one. Deep within the folds of the brain lies a network that hums with feeling. It doesn't calculate or reason. It doesn't speak in words or logic. It simply reacts, instantly, powerfully, and often before you're even aware of it. This is the limbic system, the ancient emotional core of the human mind. While the outer layers of the brain handle thought and decision-making, the limbic system is the pulse beneath it all, where fear, joy, anger, and love first take shape. At the center of this network sits the amygdala, a small almond-shaped cluster of neurons buried deep in the temporal lobe. The amygdala is the brain's early warning system, finely tuned to detect threats and opportunities alike. When something startles you, a sudden noise, a shadow in the corner of your eye, it's the amygdala that sounds the alarm. It floods the body with signals of readiness, priming the muscles, quickening the pulse, and sharpening the senses. It's fast, automatic, and utterly essential. Without it, danger might go unnoticed until it's too late. Close to the amygdala lies the hippocampus, the keeper of memory. This structure records the details of your experiences, what you saw, what you heard, what you felt, and stores them so that life can be learned rather than constantly relearned. The hippocampus and the amygdala work hand in hand. Emotion gives memory strength, and memory gives emotion context. That's why we remember moments of fear or happiness so vividly. A birthday celebration, a first kiss, a close call on the road, all become etched into memory because emotion makes them unforgettable. The hypothalamus sits just below these two structures, quietly bridging emotion and biology. When the amygdala signals danger, it's the hypothalamus that sends the body into action, releasing adrenaline and other hormones to ready you for fight or flight. It's also the part that restores calm afterward, telling your heart to slow, your breathing to deepen, your muscles to release their tension. The hypothalamus is the translator between mind and body, the reason emotions have physical sensations. Together, these structures make up the emotional foundation of the nervous system. But emotions don't live here alone. They're shaped and refined by their dialogue with newer parts of the brain, especially the cerebral cortex, the outer cortex, particularly the prefrontal region, brings reason and reflection to feeling. It's where thought meets instinct, a balancing act between impulse and control. When you feel anger but choose not to lash out, that's your cortex stepping in, calming the amygdala's fiery urgency. When fear grips you, but you remind yourself it's only thunder, that's logic soothing emotion. Yet, the balance can go both ways. The limbic system can overpower reason in a flash. A racing heart in panic, tears welling up before a word is spoken, laughter bursting out uncontrollably. The conversation between these two regions never stops. It's the essence of emotional life. Every emotion is a conversation between the ancient and the new. The limbic system speaks the language of instinct, fast, loud, and simple, while the cortex answers with thought, patience, and nuance. One without the other would leave you incomplete, pure logic without warmth, or raw instinct without understanding. Together they create the full spectrum of human experience, joy and grief, courage and hesitation, curiosity and calm. Neurotransmitters weave through the system like the colors of emotion's palette. Dopamine brings pleasure and reward, lighting up the brain when something feels good or promising. A taste of sweetness, a goal achieved, a song you love. Serotonin, by contrast, spreads a quiet sense of stability and peace, keeping mood and anxiety in balance. Adrenaline, the chemical of excitement, charges through the bloodstream during moments of urgency, giving energy to both fear and exhilaration. The interplay of these chemicals paints the emotional world in shades both bright and dark, fleeting and deep. Consider how emotion and memory intertwine. A single scent, perhaps the smoke of a fire or the perfume of someone long gone, can summon an entire scene from the past, complete with the feelings that once accompanied it. The amygdala activates, and the hippocampus retrieves the details. The light in the room, the sound of a voice, the rhythm of your own heartbeat at the time. The memory doesn't just return, it lives again, briefly reawakening the state of mind you once had. It's this binding of memory and emotion that gives our lives narrative. We don't remember everything equally. We remember what matters to us, what made us feel. The nervous system prioritizes meaning over detail. The brain, in its efficiency, knows that a strong emotional imprint is worth more than an encyclopedia of neutral facts. That's why even painful memories persist. They're lessons written in the language of feeling. The limbic system also connects emotion to motivation. Pleasure and curiosity propel you toward the world, while fear and caution hold you back when danger looms. Every decision, whether impulsive or carefully planned, has an emotional undertone. Even the most logical choices are colored by the limbic system's influence. A quiet push or pull that guides thought toward what feels right or safe or rewarding. Emotion, in this sense, is not the opposite of reason, but its companion. This delicate balance can, of course, be disrupted. When the amygdala becomes overactive, anxiety and fear can dominate perception. When the prefrontal cortex falters, impulse may take over. But more often than not, the brain maintains harmony, adjusting and rebalancing with every heartbeat. This flexibility is part of what makes emotion such a dynamic force. It adapts, learns, and evolves with experience. Emotion also plays a vital role in empathy, allowing you to feel echoes of another person's experience. Mirror neurons in the brain fire when you see someone smile or cry, reflecting their expression in your own neural patterns. It's a quiet simulation of another's state, the biological root of compassion. Through this mirroring, emotion becomes not just a private experience, but a bridge between minds. What's fascinating is that emotion is both universal and unique. The physiological roots are the same for everyone. The rush of adrenaline, the warmth of oxytocin, the serenity of serotonin. But how those feelings are interpreted depends on who you are and what you've lived through. Two people might feel the same racing heartbeat, yet one calls it fear, while the other calls it excitement. The brain interprets, labels and colors emotion based on context and memory, turning biology into meaning. This is the artistry of the emotional brain. It doesn't just react, it creates. It blends instinct with story, chemistry with consciousness, until feelings become part of identity. Every joy and sorrow leaves behind a neural trace, reshaping the circuits that will define tomorrow's reactions. Over time, experience sculpts emotion into something distinctly personal, the fingerprint of your inner world. And through it all, the brain never stops negotiating between its ancient and modern halves. The limbic system may cry out in passion, but the cortex gently reminds it to breathe. The two move together like dancers, one raw, one refined, creating a balance that makes us human. In this endless duet, emotion becomes both storm and sunlight, instinct and insight, a reflection of the mind's oldest wisdom meet in its newest understanding. Within that conversation lies the heart of being alive. Emotion is not just something that happens to you, it is the bridge between thought and experience, between what you know and what you feel. It gives depth to memory, direction to action, and warmth to reason. In the quiet exchange between neurons, chemistry becomes feeling, and feeling becomes meaning. Proof that the brain does not merely think about the world, but feels it deeply. Every experience you've ever had, every laugh, every conversation, every sight and sound, still lives somewhere inside your brain. Not as a picture or a recording, but as a pattern, a constellation of electrical connections that once flickered together and can be reignited again. Memory is not a filing cabinet where moments are stored neatly away. It's a living process, always shifting, always rewriting, constantly blending what was with what is. When you experience something new, neurons fire in response, in the hippocampus, in the cortex, and in countless other regions all at once. These cells communicate, forming a circuit of activity that represents that specific moment. The more vivid the experience, the stronger the signal. If the same circuit is activated again by repetition, reflection, or emotion, the connections between those neurons grow stronger. This process, known as long-term potentiation, is the physical foundation of learning. It's how the brain says, "This matters, remember it." At first, a new memory is fragile, like wet paint. It can be easily disrupted or overwritten, but with time and reinforcement, it dries and becomes part of the structure of who you are. Some memories fade, others merge, and a few, usually those wrapped in strong emotion, endure for a lifetime. The hippocampus plays a key role here, acting as a kind of librarian that indexes new experiences before passing them on to long-term storage in the cortex. Over time, the hippocampus steps back, allowing the memories it helped create to live independently. That's why childhood events can be remembered even decades later, long after the neurons that first encoded them have been replaced or reorganized. Emotion leaves fingerprints on memory. The limbic system, especially the amygdala, marks certain experiences as important. When something stirs deep feeling, joy, fear, excitement, the amygdala floods the brain with signals that enhance attention and storage. It's why you might remember where you were during a major event years ago, or the exact expression on someone's face during a life-changing moment. The nervous system prioritizes what moves us. Neutral moments, however pleasant, tend to drift away unless they are revisited or repeated. Sleep is another silent partner in memory. During deep sleep, especially in the dream-rich stage known as rapid eye movement sleep, the brain replays the day's experiences. Neurons fire in familiar patterns, rehearsing what you've learned, strengthening useful connections and discarding what's unnecessary. It's a nightly cleaning and organizing session, the mind's way of sorting through the day's clutter. This is why a good night's rest often makes a problem seem clearer in the morning. The brain has quietly restructured itself while you were dreaming. This ability to reshape and reorganize, to change its wiring, is called neuroplasticity. It's one of the brain's most extraordinary features. For much of history, scientists believed that the adult brain was static, its structure fixed after childhood. We now know that isn't true. Every new skill learned, every habit formed, every memory recalled subtly alters the connections between neurons. Some pathways are strengthened through use, others weaken and fade if neglected. It's a process of constant renewal, like a garden being tended by invisible hands. Neuroplasticity is what allows the brain to adapt after injury, to form new habits, and to keep learning across a lifetime. It's why you can pick up a new language at 50 or learn an instrument at 70. Each attempt builds a new circuit, and with repetition that circuit becomes part of the brain's permanent wiring. The more we engage with new experiences, the more flexible and resilient the mind becomes. Thought itself, that silent current behind awareness, arises from these same networks. It's not confined to one place in the brain. It's the movement of signals across billions of cells at once. Thoughts flicker in and out of existence, patterns of activation that shift from one second to the next, guided by memory, emotion, and attention. In a way, thinking is like weather, dynamic, unpredictable, and shaped by unseen forces. Storms of activity pass through, some leaving traces, others dissipating into silence. Every time you recall a memory, you recreate it. The act of remembering reactivates the original network of neurons, but never perfectly. New emotions, new contexts, and even the simple passage of time change the pattern slightly. The memory evolves, blending the original event with who you've become since. In this way, memory isn't just a record of the past, it's a living collaboration between yesterday and today. Even fleeting thoughts can reshape the brain. Each one sparks tiny changes in the strength of connections, adjusting the circuitry just enough to make similar thoughts easier next time. This is how practice refines skill and repetition strengthens belief. The brain is always listening to itself, responding to its own echoes. Short-term memory, the kind you use to hold a phone number long enough to dial it, relies on transient electrical activity, patterns that fade if not reinforced. Long-term memory, on the other hand, depends on physical change. New synapses forming, new proteins building bridges between neurons. What begins as a temporary spark can, with enough repetition, become part of the brain structure, a physical mark of experience. This blend of electricity and chemistry makes memory both fragile and durable. It explains why you might forget where you left your keys but recall a song lyric from childhood without effort. The brain prioritizes connections that are meaningful, emotional, or frequently used. It's not a perfect system, but it's beautifully efficient, a compromise between storage space and relevance. When people lose memories through injury or illness, it's often because these neural pathways have been disrupted. But even then, the brain finds ways to adapt. Other regions can sometimes take over lost functions, rerouting signals to restore parts of what was lost. It's a quiet testament to the resilience of this living network. Even when damaged, it seeks connection. Memory is not only about the past, it's the foundation of identity. It tells you who you are, where you've been, and what you've loved. Without it, life would be an endless present, rich in sensation, but empty of meaning. Each recollection adds texture to consciousness, layering experience into understanding. And thought, that constant hum of interactivity, relies on these same circuits. When you imagine the future, you're using the machinery of memory, recombining old experiences into something new. The same neurons that recall are the ones that dream. It's extraordinary to realize that something so intangible, an idea, a feeling, a fragment of song, can exist as a pattern of signals within the wet architecture of the brain. Every neuron that fires leaves behind a trace, a subtle shift that changes who you are, even in the smallest way. You are, quite literally, a product of your own thoughts, a living record of everything your nervous system has chosen to remember. And somewhere within that electric forest of cells, each memory waits, not as a picture frozen in time, but as potential, ready to be reawakened by a single spark. Every memory is electricity captured, a spark stored for later light. Every night as darkness settles and the body grows still, the brain begins one of its most vital tasks, the process of renewal. Sleep might appear to be a time of quiet and inactivity, but beneath the surface it is anything but silent. The nervous system, far from resting, hums with purpose. It sorts, cleans, repairs and resets, preparing mind and body for another day in the waking world. Falling asleep is not a simple switch from on to off. It's a gradual descent through distinct stages, each with its own rhythm and purpose. The first is light sleep, that drowsy edge between wakefulness and dreaming. In this stage, the brain's waves slow, muscles relax, and the senses begin to dim. You might drift in and out, still aware of faint sounds or the comfort of your pillow. It's the brain's gentle way of easing you into the deeper states to come. Then comes deep sleep, sometimes called slow-wave sleep. Here, brain activity drops into long, steady oscillations, great rolling waves that sweep across the cortex in synchrony. It is during this stage that the body performs its most important physical repairs. Growth hormone surges, muscles recover from strain, tissues rebuild, the immune system strengthens its defenses, and energy stores are replenished. This is the body's workshop, where maintenance happens quietly behind closed eyes. And yet deep sleep is also when the brain itself undergoes vital housekeeping. Inside the neural labyrinth, a special cleaning system, the glymphatic system, becomes highly active. Cerebrospinal fluid flows through channels between brain cells, flushing away metabolic waste that accumulates during the day. It's like a nighttime tide washing through the mind, removing the microscopic debris of thought and activity. Without this nightly cleansing, toxins can build up, clouding mental clarity and disrupting long-term health. After deep sleep comes a curious return toward wakefulness, rapid eye movement sleep or REM. In this stage, the brain's electrical activity looks almost identical to that of waking life. The eyes dart beneath closed lids, muscles temporarily paralyzed to prevent movement, and dreams unfold in vivid scenes of imagination. It's here that the nervous system begins its emotional and cognitive reorganization. Dreaming is one of biology's most poetic inventions, a nightly rehearsal of life, both real and imagined. In REM sleep, the brain weaves together fragments of memory, emotion, and experience, finding meaning in chaos. It tests scenarios, practices responses, and integrates new information into the architecture of memory. That strange dream where you're running through a city made of glass, chased by a childhood teacher holding a clock. That's your nervous system filing paperwork, blending the day's impressions with older memories, sorting them into emotional order. Even your neurons have night shifts. While you drift through sleep, they are busy rerouting connections, pruning unnecessary ones, and strengthening those that matter. If you practiced a skill during the day, playing an instrument, learning a new word, solving a problem, the circuits that supported that activity are reactivated in your dreams. The brain quietly rehearses the pattern, reinforcing it. By morning, the skill is a little more refined, the memory a little more stable. Sleep, quite literally, makes learning permanent. The process isn't uniform. The brain cycles through light, deep and REM sleep several times each night in patterns of roughly 90 minutes. Each cycle has its own emphasis, the early ones heavier on deep sleep, the later ones richer in dreams. As morning approaches, REM stages lengthen, allowing more time for integration and emotional processing. It's one reason waking from a dream can feel so vivid. You've caught the brain in the act of storytelling. While the mind performs its nocturnal work, the autonomic nervous system shifts into its most restorative mode. The parasympathetic branch takes the lead, lowering heart rate and blood pressure, slowing breathing, and directing energy toward repair. Digestion and immune function flourish in this calm environment. Meanwhile, the body's temperature drops slightly, signaling rest to every cell. The entire organism moves into a synchronized state of recovery. Emotionally, sleep acts as the great regulator. During wakefulness, the amygdala, the brain's emotional alarm system, can become overactive, especially under stress. But in REM sleep, this system is soothed and recalibrated. Dreams replay difficult experiences in a low-stakes environment, softening their impact. It's as if the brain performs its own therapy session, reframing emotions and filing them neatly away. That's why a good night's sleep can make yesterday's worries feel less overwhelming. Insufficient sleep, on the other hand, disrupts this delicate balance. Memory weakens, reaction times slow, and emotions become less stable. The amygdala becomes jumpier. The prefrontal cortex, responsible for reasoning and control, grows sluggish, and the dialogue between them falters. In short, sleep deprivation doesn't just make you tired, it makes you less yourself. The nervous system depends on rest to remember who it is. Even as consciousness fades during sleep, the brain remains alert to safety. A faint sound, a shift in light, or a familiar voice can pierce the veil of slumber instantly. This vigilance is a remnant of evolution, when survival depended on waking quickly to danger. It's the reason parents can sleep through a storm but awaken the moment their child murmurs in another room. The nervous system never fully powers down. It simply lowers the lights and works quietly in the background. Throughout the night, electrical rhythms in the brain create waves of communication between regions that rarely synchronize during the day. The hippocampus and cortex exchange information, transferring short-term memories into long-term storage. The prefrontal regions rest and reset, improving focus and creativity for the day ahead. In some ways, sleep is a nightly reboot, clearing caches, updating programs, and patching emotional software. For all its mystery, sleep is one of the most democratic forces in nature. Every creature with a nervous system, from insects to whales, needs it. It's an evolutionary truth that rest is as essential as food or air. Even fruit flies deprived of sleep become disoriented, their tiny brains unable to process information properly. The pattern of active wakefulness followed by restorative stillness is written into the code of life itself. It's remarkable to realize that while you lie still, eyes closed and mind adrift, the brain is perhaps more dynamic than during the day. It solves problems, repairs damage, balances hormones, and reweaves the intricate fabric of the self. The sleeping brain doesn't idle. It creates, curates, and restores. And when dawn finally arrives and light filters through your eyelids, the nervous system shifts its tempo once again. Heartbeat and breathing quicken, hormones rise, and the cortex brightens to meet the world anew. You awaken refreshed not by chance but by design. the product of countless cellular repairs and recalibrations made in the quiet hours of night. So the next time you feel guilty for dozing off or taking an early night, remember that sleep is not a luxury or a pause from life's progress. It is progress, a fundamental act of renewal written into the biology of every living thing. The nervous system, like any fine instrument, needs tuning to stay in harmony, and as you drift off tonight, perhaps you'll take comfort in knowing that even as your mind wanders into dreams, the rest of you is hard at work. Neurons filing, cleaning, repairing, and remembering. Rest is not idleness. It's repair in progress, the body's most peaceful form of perseverance. Pain is one of the most universal experiences of being alive, and yet one of the least welcome. It's the body's alarm, a language spoken in sensation rather than words, a signal that something needs attention. But though it may feel like punishment, pain is not cruelty. It is communication. Without it, life would be far more dangerous, and the body would quietly break itself without ever noticing. The process begins at the edge of awareness, in the skin, the joints, the muscles, and deep within the organs. Scattered throughout these tissues are specialized nerve endings called nociceptors, whose only job is to detect potential harm. They're the sentinels of the nervous system, constantly on patrol for anything that threatens to damage the body. When they sense danger, heat, pressure, chemicals from injured cells, they send an urgent signal through sensory nerves toward the spinal cord and from there to the brain. The sensation that follows isn't automatic, it's constructed. The brain receives those signals and interprets them as pain. That interpretation can change depending on context. The same physical injury might feel worse when you're scared and barely noticeable, when you're distracted or motivated. Pain, in other words, is not just a physical event but a psychological one too, shaped by mood, expectation, and memory. There are many types of nociceptors, each finely tuned to a different kind of danger. Some respond to temperature, the searing heat of a flame, or the numbing cold of ice. Others react to mechanical pressure, like a sharp cut or a twisting sprain. Still others respond to chemical signals released by damaged tissue, which can make the area more sensitive and inflamed. Together, they create a precise sensory map of distress, allowing the brain to locate the problem and decide how best to protect it. Acute pain is the body's rapid response system, immediate, sharp, and purposeful. It tells you to pull your hand from a hot stove, to rest a twisted ankle, or to stop biting your tongue. This type of pain is fast and usually fades once the threat is removed and healing begins. It's an essential feedback loop. Injury leads to sensation, sensation leads to protection, and protection leads to recovery. Chronic pain, however, is a different story. It's the alarm that won't stop ringing even after the fire is out. Sometimes nerve pathways remain active long after the original injury has healed, misfiring or amplifying signals. Other times, the brain itself becomes hypersensitive, reinterpreting harmless signals as painful. Chronic pain can linger for months or years, turning from a warning into a burden. It shows how the same system that protects us can, when unbalanced, become its own source of suffering. To keep pain from overwhelming us, the body has its own built-in relief system. The brain and spinal cord release natural chemicals called endorphins, short for endogenous morphines. These molecules bind to special receptors in the nervous system, dulling the sensation of pain and replacing it with a feeling of calm or even euphoria. They're part of the reason athletes can push through exhaustion, or why laughter can sometimes make an ache seem to fade. Endorphins are the body's quiet promise that pain, though necessary, will never go completely uncomforted. The brain doesn't simply receive pain, it moderates it. Regions such as the thalamus and anterior cingulate cortex act like volume knobs, amplifying or dampening the signals depending on attention, emotion, and expectation. If you're focused elsewhere, pain can fade to the background. If you anticipate it or fear it, the signal can grow louder. This modulation is why psychological factors, stress, anxiety, even hope, can profoundly influence physical suffering. The nervous system is not a static machine. It's a living dialogue between body and mind. There are moments when this system bends the rules entirely. In emergencies, adrenaline surges can temporarily mute pain altogether. Soldiers wounded in battle or athletes injured mid-play often report feeling nothing until after the crisis has passed. The brain, prioritizing survival, delays the message until safety returns. Only then does the pain rush in, the body's way of saying, now that you're safe, it's time to heal. Pain also has a curious connection to learning. Every time it warns you away from harm, it's shaping behavior. This sting of touching something hot teaches caution. The ache of overexertion reminds you of your limits. Even emotional pain serves a similar role, steering you away from situations that once hurt. It's not pleasant, but it's effective, a system honed by evolution to ensure survival through awareness. And yet, pain is deeply personal. No two people experience it the same way. Cultural beliefs, genetics, memory, and even upbringing can shape how pain is felt and expressed. Some find meaning in it, seeing it as a measure of endurance or growth. Others see it as an obstacle to be conquered. Science has mapped the nerves and chemicals behind it, but its full experience remains uniquely human, an intersection of biology and consciousness. Interestingly, the nervous system can sometimes create pain without injury at all. Phantom limb pain, experienced by amputees, is one of the most striking examples. Even after a limb is gone, the brain's representation of it remains active. When those circuits fire, the brain interprets them as pain from the missing part, proof that pain is as much an event of perception as it is of flesh. The line between physical and emotional pain is thinner than it seems. Both activate many of the same regions of the brain. A broken heart and a broken bone are processed by overlapping neural circuits, which is why emotional distress can ache in the body and physical pain can affect mood. The brain doesn't distinguish sharply between the two because, in evolutionary terms, both threaten well-being. Pain, whether physical or emotional, is a call for attention, a signal that something vital needs care. Endorphins aren't the only messengers of comfort. The nervous system also engages dopamine, oxytocin, and serotonin, chemicals associated with reward, bonding, and calm touch. Laughter, connection, and even music can stimulate their release, softening pain's edge. The body, in its quiet wisdom, knows that comfort is a kind of medicine too. It's worth remembering that pain, for all its intensity, is not the enemy. It's the reason a child pulls away from a flame, the reason an injury heals without worsening, the reason you instinctively protect what is wounded. In this sense, pain is a guardian, blunt, insistent, but ultimately benevolent. It doesn't seek to harm, it seeks to help. In modern medicine, the challenge is not to eliminate pain entirely, but to understand it, to listen to what it's saying. There are times when it misfires, times when it exaggerates, and times when it refuses to quiet down. But in its purest form, pain is truth spoken by the body. It is awareness made physical, a plea for rest, adjustment, or healing. So while it may never be welcome, pain has purpose. It keeps us from repeating injury, alerts us to imbalance, and teaches us what to protect. It connects us more deeply to the body we inhabit, reminding us that living means feeling, the full spectrum of sensation, from pleasure to ache. In the end, pain is not a punishment but a partnership. It speaks, we respond, and in that dialogue lies the wisdom of survival. It may shout when it needs to, or whisper when it can, but its message is always the same. Pay attention. Pain is the body's whisper, asking for care. Deep in the quiet chambers of the abdomen lies a nervous system that most people don't realize exists, one that can think, react, and even feel in its own mysterious way. It's called the enteric nervous system, and it lives woven through the walls of the digestive tract. Scientists sometimes call it the second brain, and it earns the title honestly, with over 500 million neurons, more than the spinal cord. It controls digestion, senses the chemical world within, and sends messages constantly to the brain above. This second brain doesn't dream or philosophize, but it is astonishingly independent. It can coordinate the entire digestive process on its own, from the first swallow to the last movement of the intestines, without any direct orders from the brain. If the brain in your skull is the commander-in-chief, the enteric system is the seasoned general who knows exactly what to do. Every contraction of the gut, every release of enzyme, every careful sorting of nutrients and waste is guided by its intricate web of neurons. Yet this is no silent partnership. The enteric nervous system and the central nervous system are in constant conversation, exchanging information along a superhighway of nerves. The most important of these is the vagus nerve, a long wandering strand that connects the brainstem to nearly every organ in the body. It carries not only commands downward, regulating heart rate, breathing and digestion, but also streams of sensory information upward, letting the brain know exactly how the body feels. In fact, around 90% of the signals travelling along the vagus nerve go from the gut to the brain, not the other way around. This means that your stomach is often the one sending instructions, not just receiving them. When you feel a flutter of nerves before a big event or a sinking sensation during stress, that's your gut speaking first. The tightness in your abdomen before an exam, the loss of appetite when anxious, the warmth of comfort food when relaxed. These are the body's ways of translating emotion into digestion, and digestion into emotion. Your gut feelings aren't just metaphors, they're messages. The connection runs deeper than nerves alone. Inside the intestines lives a vast community of microorganisms known collectively as the gut microbiome. Trillions of bacteria, fungi and other tiny life forms that help digest food, produce vitamins, and regulate the immune system. But these microbes also talk to the nervous system. Through chemical signals and by influencing the production of neurotransmitters like serotonin, dopamine, and GABA, they can subtly shape mood, cognition, and even behavior. It might sound strange, but much of your body's serotonin, the chemical associated with calm and well-being, is produced in the gut, not the brain. Specialized cells lining the intestines release it in response to signals from both neurons and microbes. In turn, the vagus nerve carries that information upward, influencing how you feel. The gut and brain form a feedback loop of chemistry and electricity, adjusting each other moment by moment. When the gut is balanced and healthy, communication flows easily. The microbiome thrives, the enteric neurons perform their work smoothly, and the signals sent to the brain are steady and reassuring. But when the system is disrupted by stress, illness, or poor diet, the dialogue can become confused. Inflammation in the gut can trigger anxiety in the mind, and anxiety can further disrupt digestion, creating a cycle that feeds itself. It's a conversation that can turn into an argument if one side grows too loud. Scientists are only beginning to understand the full extent of this connection. Studies have shown that changes in gut bacteria can alter emotional responses, decision-making, and even social behavior in animals. In humans, emerging research suggests that probiotics, the so-called good bacteria, may help alleviate certain mood disorders. The gut, it seems, is not merely a digestive organ. It is part of the emotional circuitry of the body. The relationship between gut and brain is especially evident during stress. When the sympathetic nervous system activates, preparing you for fight or flight, the digestive process slows. Blood flow is redirected away from the stomach and intestines toward the muscles and heart. The gut's rhythm pauses, waiting for safety to return. Once calm is restored, the parasympathetic system, working largely through the vagus nerve, brings digestion back online. You might even hear your stomach growl as peace resumes, the body's soft reminder that it can now focus on nourishment instead of survival. In calmer moments, this system plays an equally important role in emotional grounding. A full, healthy gut releases signals of satisfaction and comfort, not just to regulate appetite, but to foster a sense of well-being. This may be one reason why people instinctively seek food during emotional moments. It's not only a craving for flavor, but a subconscious attempt to restore internal calm. The gut doesn't just digest what you eat. It digests how you feel. Even the immune system listens to the conversation. The gut's lining is home to a vast network of immune cells constantly sampling what passes through, deciding what's friend and what's foe. These cells communicate directly with both enteric neurons and the brain through chemical messengers. When the microbiome is balanced, this network works in harmony, training the immune system to stay calm yet vigilant. When it's disrupted, inflammation can spread, affecting not only digestion but mood and mental clarity as well. This integration of body and mind reveals something profound about how we experience the world. Thoughts can make the stomach twist. A meal can change the tone of thought. The connection is not a metaphor or a superstition. It is the biological truth of being human. The nervous system doesn't recognize clear borders between gut and brain, emotion and digestion. They are threads of the same fabric, weaving sensation, mood, and instinct together. And though it's easy to think of intelligence as something that lives solely in the head, much of what keeps us alive and balanced begins in the gut. It operates with quiet wisdom, responding instantly to shifts in our inner and outer environment. When the mind is anxious, the gut tightens. When the body relaxes, it releases. You might call it intuition, but it's also physiology. The nervous system reading the world through the body before consciousness even arrives. This partnership between gut and brain may explain why certain practices, deep breathing, mindfulness, gentle eating, have such powerful effects on mood. When you calm the body, you calm the gut. When you calm the gut, the brain listens and follows suit. The vagus nerve is the messenger in both directions, carrying reassurance as readily as alarm. It is the thread of peace that can be plucked to quiet the whole system. Your digestive system is more than a mechanical process. It's a living dialogue of chemistry, neurons, and emotion. Every meal you eat, every feeling you have, Every breath you take subtly shapes the signals flowing between gut and brain. It's not mind over matter or matter over mind. It's both, endlessly intertwined. So the next time you feel butterflies in your stomach, or a warmth that spreads after a comforting meal, remember that your nervous system is talking to itself. Your instincts, your moods, your sense of calm. They're all part of the same conversation. The gut and the brain are partners in perception, co-authors of emotion. And through every whisper, grumble, and flutter, they remind you that your feelings are not just in your head. Your gut feelings aren't just metaphors. They're messages, delivered from one brain to another, echoing softly through the body's quiet intelligence. For all its complexity and brilliance, the nervous system is still a delicate network, a symphony of signals that depends on balance, timing, and harmony. When that harmony falters, the effects can ripple through thought, movement, and sensation. Yet even in its moments of fragility, the nervous system remains remarkable for one reason above all: its ability to adapt, to heal, and to find new ways forward. Every neuron, every pathway, every connection in the brain and body depends on the faithful transmission of signals. When those signals are interrupted, by injury, by illness, or by chance, the conversation within the body becomes distorted. But even then, the system doesn't simply give up. It listens, recalculates, and searches for detours, like a city rerouting its traffic after a bridge closes. Take, for example, multiple sclerosis, often called MS. In this condition, the protective coating around nerve fibers, the myelin sheath, becomes damaged. Myelin acts like insulation around electrical wires, ensuring that messages travel swiftly and accurately. When it wears away, signals can slow or scatter, leading to fatigue, weakness, or blurred sensation. Yet even here, the body tries to repair itself. Cells called oligodendrocytes can rebuild portions of the myelin, and the brain reroutes communication to compensate. People living with MS often experience cycles of challenge and recovery, showing just how determined the nervous system is to maintain its connections. Then there is Parkinson's disease, a condition that affects movement. Deep inside the brain, a small cluster of cells in a region called the substantia nigra gradually loses its ability to produce dopamine, the chemical that helps coordinate motion. Without enough dopamine, movements can become slow or tremulous, as if the orchestra of the body were missing its conductor. Yet the story of Parkinson's is not only one of loss, but of adaptation. Exercise, medication, and modern therapies help restore rhythm to the system. Some patients receive deep brain stimulation, tiny electrodes implanted in precise regions of the brain that deliver carefully timed electrical impulses. These signals, like gentle nudges, help the neural circuits find their beat again. Epilepsy, too, reveals both the vulnerability and the resilience of the brain. It occurs when groups of neurons begin firing together in sudden bursts of excessive activity, creating what we know as seizures. But even within this storm of miscommunication, the nervous system holds immense potential for recovery and regulation. With medication, careful management, and in some cases surgery or targeted electrical therapy, many people lead full, balanced lives. The brain, after all, is not static. It learns from experience, even from its own mistakes. That ability to learn and adapt is called neuroplasticity, and it is one of nature's quiet miracles. For much of scientific history, it was believed that the adult brain could not change, that once damaged, it was forever fixed. But the truth is far more hopeful. Neurons can form new connections, neighboring regions can take over lost functions, and unused pathways can awaken when needed. A stroke that damages speech, for instance, might lead nearby cells to reorganize and rebuild communication. With time, patience, and training, the brain can often write new scripts over old scars. This same principle fuels much of modern rehabilitation. After nerve injury or trauma, physical therapy and retraining exercises encourage the nervous system to rewire itself. Even the simple act of trying, of imagining a movement or attempting it, sparks activity in the brain that strengthens surviving pathways. Every repetition is a signal saying, "Try again," and the system listens. Injuries to the spinal cord, once considered beyond repair, are now at the forefront of astonishing research. Scientists are exploring nerve grafts, stem cell therapies, and regenerative treatments that coax neurons to reconnect across damaged regions. Electrical stimulation can awaken dormant pathways, allowing signals to travel once more. Some patients who were once completely paralyzed have taken their first steps again, guided by the patient persistence of technology and biology working together. Then there are the marvels of prosthetic control, artificial limbs that can move not through buttons or levers, but through thought. Electrodes placed on the skin or connected to nerves pick up the faint electrical whispers of intention, translating them into motion. A person can think open hand, and the prosthetic responds, opening with grace and precision. It's the nervous system extended beyond the body, proof that even when signals falter, communication can continue in new forms. Brain-computer interfaces push this boundary even further. These systems translate neural activity directly into digital signals, allowing people to move cursors, control robotic arms, or even type words using only thought. For those who have lost speech or mobility, such technologies offer not just function, but dignity, a reconnection to the world through the language of neurons. It's a reminder that the nervous system, though fragile, is infinitely adaptable when given a chance. Even outside laboratories, recovery takes countless quiet forms. When a person learns to walk again after a stroke, when memory slowly returns after injury, when tremors calm with therapy. These are moments of triumph built on the same foundation of resilience. The nervous system never stops trying to restore balance. It constantly rewires, reconfigures, and redefines its pathways, guided by use, repetition, and hope. Of course, healing isn't always complete. Some signals never return to their full strength, and some pathways remain broken. But even then, the body finds workarounds. The brain is full of redundant circuits, alternate routes that can be strengthened with practice. When one road closes, another opens, even if it's slower or narrower than before. That quiet determination, written into the nervous system's design, is what makes recovery possible. What's perhaps most moving about this process is how intertwined the biological and emotional aspect of healing are. The same chemicals that influence thought and mood also shape recovery. Motivation releases dopamine, which encourages neurons to strengthen their connections. Hope, though intangible, has a biological echo, a measurable impact on healing. The mind doesn't just observe recovery, it participates in it. Medicine too continues to evolve in harmony with the nervous system's adaptability. Researchers are growing neural tissue in the lab, developing therapies that encourage regeneration, and experimenting with artificial synapses that could one day repair damaged communication. Scientists have even begun using light-sensitive proteins to control neurons, a field called optogenetics. which may allow precise treatment of disorders like epilepsy or Parkinson's without invasive surgery. Each new discovery brings the promise of clearer signals, steadier motion, and renewed sensation. Yet even with all our knowledge, there is something quietly humbling about how much the nervous system can do on its own. Healing often begins in small, unseen ways. A nerve sprouting a new branch, a connection strengthening with use, a brain cell finding a new partner to talk to. Recovery is rarely instant, but it is always possible in some form. Even when signals fade, the system searches for a new path. The nervous system's resilience mirrors our own. It adapts to loss, finds ways to communicate through silence, and learns to balance on unfamiliar ground. It is both fragile and fierce, delicate in its design, yet relentless in its desire to reconnect. Within every flicker of restoration, every regained movement or sensation, there is proof of the body's most hopeful truth. That connection, once lost, can sometimes be found again. So while the nervous system may falter, it never fully fails. It bends, it reroutes, it rebuilds. It listens to every attempt and answers with possibility. Beneath every effort to heal, every rehabilitation, every experiment, every small victory, lies the same quiet message, shared by neurons and humans alike. Keep trying. The signals will find their way. Somewhere within the vast web of neurons that fill the skull, a quiet miracle takes place. Electricity and chemistry, which on their own have no awareness, combine to produce something entirely new. The sense of being. Out of the countless cells exchanging signals in rhythmic harmony, emerges the strange, steady glow of consciousness, the experience of knowing, of feeling, of existing at all. Every thought, every memory, every flicker of emotion begins as a pattern of neural activity. Yet somehow, from these electrical whispers arises something far greater than the sum of its parts, a mind aware of itself. A neuron cannot think or feel alone, but when billions of them communicate together, awareness seems to bloom like light through stained glass. The human brain is often described as the most complex structure in the known universe. Around 86 billion neurons, each connected to thousands of others, form trillions of tiny junctions. These connections are not static. They change every second, strengthening, weakening, rearranging. Within this living circuitry, waves of activity flow and meet, merging into patterns of astonishing intricacy. Somewhere in that constant conversation, a voice appears. The quiet awareness that says, "I am." Scientists have spent centuries trying to understand how this transformation happens, how matter gives rise to mind. Many theories have been proposed, each offering a glimpse of possibility without quite capturing the full mystery. One is called the integration theory, the idea that consciousness arises when information from across the brain becomes unified, when countless signals combine into a single, coherent whole. According to this view, awareness is the brain's way of gathering its scattered experiences into one luminous point of understanding. Another is the synchronization theory, which suggests that consciousness emerges from timing, the rhythm of neurons firing together in precise coordination. Just as musicians playing in unison create melody, synchronized neural activity may form the harmony of thought and perception. These fleeting bursts of coordination, measured in thousandths of a second, could be the physical rhythm of awareness itself. A third idea, the global workspace theory, paints consciousness as a kind of stage. On this stage, Information from different parts of the brain is gathered, spotlighted, and made available to other systems. Most brain activity happens backstage, automatic, unconscious. But the moments that reach the global workspace are the ones we experience as conscious thought. In this model, awareness is less a substance than a performance, a spotlight moving gently from one mental scene to the next. Each theory captures a piece of the puzzle, yet none explains how electrical activity, which can be measured, becomes subjective experience, which cannot. No microscope can detect a thought, and no scanner can display the texture of a feeling. We can trace every signal through the nervous system, yet we still don't know how those signals turn into the warm glow of awareness, the inner life that makes being human so extraordinary. Perhaps that's because consciousness isn't a single thing, but a process, an ongoing dialogue between brain and body, between perception and memory. It may not reside in one region or circuit, but in the constant integration of all of them. The mind, after all, is not separate from the body. It's the body's interpretation of itself, a reflection formed from the signals flowing through every cell. When you see a sunset, the experience feels immediate. The colours, the calm, the sense of wonder. But what actually happens is a cascade of events. Light hits the retina, signals travel through the optic nerve, neurons in the visual cortex interpret shapes and hues, and networks across the brain link those perceptions to memory and emotion. Out of this immense complexity arises a single, unified moment, you watching the sunset. Consciousness also has layers. There's the awareness of the world around you, the sights, sounds, and sensations that define the present, and the deeper awareness of yourself observing it. This inner perspective, this sense of continuity over time, is what makes the mind feel personal. It's the difference between a camera recording a scene and a person standing within it, knowing they're part of it. The nervous system seems to weave this sense of self from many threads. Memory provides continuity, emotion gives meaning, and attention focuses awareness on what matters most together. They form a fabric of identity that feels whole, even though it's built from countless shifting parts. The you that exists right now is not exactly the same as yesterday's version. The neurons have changed, the connections evolved, yet the pattern remains familiar enough to feel like one continuous being. Some scientists propose that consciousness might simply be what happens when information reflects upon itself, when the system that processes reality also processes the fact that it is processing. In this view, awareness is the brain's way of monitoring its own activity, like a mirror that reflects its own reflection. It's a poetic notion, but one that feels fitting. The universe, through us, becoming aware of its own existence. And yet the deeper we look, the more elusive the answer becomes. No single neuron holds consciousness. No region alone produces it. It arises only in the vast collective, in the dynamic interplay of signals that never stop shifting. It may be that consciousness is not a property of matter at all, but a pattern, a state that emerges whenever complexity reaches a certain threshold. If so, then awareness might be a fundamental aspect of the universe, appearing wherever the right conditions allow it to flicker into being. For all our progress, consciousness remains the most intimate mystery we know, one we can experience directly, yet never fully explain. It's both ordinary and transcendent, the simple act of being awake, and the profound question of what being truly means. Every scientific discovery brings us closer to understanding the brain, but the leap from neurons to awareness is still shrouded in wonder. Perhaps that's part of its beauty. Consciousness may never be something we solve, but something we continually explore. Each thought, each dream, each act of perception adds to its unfolding story. The nervous system, in its endless activity, doesn't just process the world, it creates a space within which the world can be known, felt, and remembered. If you could step back and listen to the brain at work, it might sound like music. Billions of notes playing together in endless variations. Most of the time, that music hums quietly, a steady rhythm of perception and response. But sometimes it swells into awareness, into the realization that you are listening, thinking, wondering. Perhaps consciousness is the quiet hum of matter realizing itself. In the end, the conscious network of the nervous system is both a scientific marvel and a philosophical invitation. It asks not just how we think, but what it means to be. The neurons that fire within your skull are the same kind of matter that forms stars and oceans, yet arranged in such a way that they can look inward and ask questions about themselves. It is perhaps the universe's most astonishing trick and its most beautiful one. So as you breathe, think, and drift through the quiet corridors of awareness, remember that this experience, this inner light that notices the world, is one of the rarest phenomena we know. It is fragile, fleeting, and precious. And though we may never fully understand how the symphony of neurons becomes the song of the self, we can marvel at its melody, the sound of the universe briefly knowing that it exists. Every heartbeat, every breath, every flicker of thought or feeling depends on a single, invisible network, the nervous system. It is the quiet conductor that keeps the body in time, ensuring that every organ, cell, and sense plays its part in the endless music of life. From the neurons in the brain to the nerves in the fingertips, from the reflexes that act before awareness to the thoughts that shape identity, all are joined in a choreography so seamless that you rarely notice it at all. You're a symphony of signals tuned by evolution to stay in balance. Every note, each electrical pulse, each chemical whisper resonates through the body in perfect correspondence. The nervous system does not simply control, it connects. It allows the heart to listen to emotion, the muscles to obey intention, and the senses to feed the mind. It is the bridge between thought and action, between consciousness and the quiet intelligence of the body. The journey of understanding it begins with its structure, a vast communication network made of the brain, the spinal cord, and the branching web of peripheral nerves that reach every cell. The brain interprets the world, the spinal cord carries its instructions, and the peripheral nerves deliver them to where they are needed most. Together they create continuity, a living circuit that loops endlessly from perception to response and back again. Think of the heart. It beats under the guidance of electrical rhythms, shaped subtly by the autonomic nervous system. When stress rises, sympathetic signals increase the pace, preparing the body for action. When calm returns, parasympathetic currents slow the rhythm once more. The lungs respond too, matching breath to emotion. Even digestion joins the orchestra, pausing or resuming its flow in step with thought and mood. These countless adjustments happen in silence, maintaining equilibrium no matter how the world shifts around you. The nervous system's reach is everywhere. It tells muscles when to contract and glands when to release. It keeps temperature steady, pupils responsive, posture aligned. And while it may seem mechanical in description, its performance is anything but. There's elegance in the way it balances alertness with rest, strength with sensitivity. It doesn't simply react, it predicts, constantly anticipating what the next moment will require. All the elements explored so far, movement, emotion, memory, sleep, and sensation, are not separate functions but threads of one fabric. The brain's motor regions don't move muscles alone. They collaborate with sensory feedback from the skin and joints, and with the cerebellum's delicate timing. The emotional centers, once thought to exist in isolation, are deeply entwined with physical responses, a heartbeat quickening with fear, a breath slowing with contentment. Even the process of thought itself relies on signals that originate far beyond the skull. The body and brain are partners engaged in a conversation as old as life itself. When emotion rises, the nervous system carries its echo into the body. Muscles tense, stomach tightens, breathing changes. When the body relaxes, the message travels back upward, calming the mind. It's a constant dialogue, the gut sending signals through the vagus nerve to influence mood, the brain adjusting hormones to restore balance. Each system listens and responds, never fully in charge, never fully subordinate. Together they maintain the delicate poise that makes you feel whole. Even the simplest actions, opening your eyes in the morning, turning your head toward a sound, are miracles of coordination. The visual system alerts the motor system, the cerebellum fine-tunes movement, and the sensory nerves confirm success. You're aware of a single gesture, but millions of neurons contribute to it. Every step you take requires split-second decisions by reflex arcs in the spinal cord, balancing by adjustments you never consciously notice. Awareness floats on top of all this activity, like a melody carried on the hum of countless instruments playing in sync. When you rest, the same harmony continues in a quieter key. During sleep, neurons shift their rhythm, replaying the patterns of the day to strengthen memory and repair the mind. Even in dreams, the nervous system rehearses movement, emotion, and thought, as if the orchestra keeps practicing long after the audience has gone home, and when you wake, the tempo rises again. Signals spark through the senses, consciousness rekindles, and the performance resumes. This constant activity is not chaos. It's guided by balance, what scientists call homeostasis. The nervous system monitors every parameter of life: temperature, pressure, energy, oxygen, pH. It senses even the smallest deviation and makes adjustments with exquisite precision. It's not just a regulator, but a guardian of continuity, ensuring that the conditions for life remain steady even as the environment changes. When one part falters, others adapt. The brain reroutes around injury, the spinal cord refines reflexes, the peripheral nerves rebuild connections. The body's resilience depends on this plasticity, the ability to change while staying whole. This adaptability isn't just mechanical, it's an expression of a life's persistence, the nervous system's determination to keep the music going even if some notes must be rearranged. Emotion, movement, thought, and rest all flow through the same current. The neurotransmitters that spark action in one moment become the messengers of calm in the next. Dopamine, serotonin, acetylcholine. These are not just molecules of chemistry, but tones in the body's symphony, creating shifts in rhythm and colour that define mood and attention. Every thought you have, every heartbeat, every sigh or smile is written in their quiet fluctuations. To think of the nervous system only as a network of cables and currents would be to miss its poetry. It's not merely the machinery of life, it is life's expression. It allows a thought to become a gesture, a sensation to become meaning, a moment of emotion to become memory. It binds the abstract to the physical, making the intangible real. Through it, mind and body cease to be separate concepts and become one continuous field of experience. This unity is what makes human existence both fragile and profound. The nervous system is delicate. A small imbalance can ripple across the whole, yet it is also deeply resilient. Its rhythm continues through exhaustion and stress, through joy and despair, through every heartbeat of a lifetime. It listens, adapts, and endures. If you could see yourself from within, you would witness a masterpiece of motion and communication. Billions of neurons firing in sequence, sending their signals through nerves that thread the body like lines of light. Each pulse carries a message of movement, sensation, memory or thought, all woven into a single flowing harmony. You're not a collection of parts. You're an unfolding pattern of coordination, alive in every instant. And in that pattern, something greater emerges: awareness, intention, connection. The nervous system doesn't just sustain life. It gives life its shape, its continuity, its sense of self. It is both the messenger and the message, both the rhythm and the song. As the orchestra of the body plays on, neurons flickering, muscles responding, organs communicating, the melody of existence continues. The nervous system holds it all together. The pulse, the motion, the thought, the feeling. It is the quiet bridge between the physical and the conscious, the thread that ties the body to its own awareness. And somewhere within that ceaseless harmony, you can sense it. The gentle balance that makes life possible, the unity between motion and stillness, thought and feeling, body and mind. It is the rhythm beneath every heartbeat, the whisper between every breath. The body in harmony, a living symphony that has played unbroken since the first spark of life began to think, to feel, and to be. From the moment a tiny pulse first shimmered within an embryo, your nervous system has been awake. Before you took your first breath, before you opened your eyes to the light of the world, it was already humming, a faint current rippling through new tissue, mapping sensation and possibility. It is the oldest rhythm you carry, older even than memory. Every heartbeat, every thought, every dream since has followed that same steady pulse, the quiet electricity of being alive. The nervous system is at once structure and story. It begins with atoms, ordinary elements forged in stars that assemble into cells capable of sending signals across microscopic distances. From there, those signals grow into networks, and those networks into awareness. It's an extraordinary lineage, from the dust of the cosmos to the architecture of the mind. The same particles that once drifted through ancient nebulae now dance through your neurons, carrying thoughts instead of starlight. Each flicker of electricity within you is a message. Some of these messages make muscles move, others shape emotions or summon memories from the past. They travel through the body in elegant patterns, a choreography of ions and impulses that together form the experience of living. Every moment you've ever known, each laugh, each fear, each late-night thought has been written not in ink, but in voltage, flashing briefly before fading into the next. The brain itself is a landscape of light and shadow, never still, always in motion. Signals leap across synapses by the millions every second, forming constellations of meaning that last only as long as attention holds them. The mind is like the night sky in motion, a billion tiny sparks, each one a fragment of consciousness, joining for a moment to illuminate thought. If the body is a vessel, the nervous system is the sea inside it, restless, luminous, and alive. And though we often imagine ourselves as separate from nature, the truth is that the same forces that shape weather and waves shape us. The nervous system obeys the same physical laws that govern lightning in the sky, the same flow of energy that once powered the stars. You are quite literally a spark of life wearing a cozy blanket of biology. Beneath your skin, the universe continues its experiment in awareness. Electricity slowed and shaped into thought, emotion, and identity. It's humbling to realize that all of this complexity began with something so simple, a signal passing from one cell to another. That signal evolved over millions of years into reflexes, instincts, and eventually imagination. The nervous system didn't just allow life to move, it allowed life to notice that it was moving. It made curiosity possible, and wonder and memory. Through it, the cosmos learned to look back at itself and ask questions. Even now, that same current runs quietly within you. When you reach for a cup or recall a name or close your eyes in thought, it's the nervous system that makes it happen. A billion tiny switches turning on and off in perfect sequence. It feels effortless, but beneath that ease lies a universe of precision. Your nerves carry signals faster than lightning can travel through the sky, yet they do so with gentleness, with just enough power to move, to feel, to think. In sleep, those signals soften but never cease. The body rests, but the nervous system continues its steady hum, guiding breath, balancing heartbeats, weaving dreams from memory. Even in stillness it listens, to the world, to the body, to itself. It is the continuity that links yesterday to tomorrow, the one companion that has never left your side. From your first kick in the womb to your quietest moment of rest, it has been there, whispering life into every cell. The nervous system is not just an instrument of survival, it's the author of experience, the reason sunlight feels warm, why music stirs emotion, why thought can turn into laughter. Through its pathways, chemistry becomes consciousness. It doesn't merely record the world, it paints it, interpreting vibration as sound, photons as colour, and pressure as touch. It creates a private universe inside every mind, no two quite the same, yet all built from the same electrical alphabet. That universe is always changing. Every new sensation, every idea, every encounter leaves its trace. The brain rewires, connections shift, and the story evolves. You are, in every moment, a living draft, a self continually written and rewritten by the nervous system's quiet hand. What you feel as identity is not static, but dynamic, shaped by the continuous movement of signals between brain and body and world. Sometimes it's easy to forget how remarkable this is, that the simple act of noticing, of thinking I am, requires a harmony so intricate that no machine has yet come close to replicating it. You are a masterpiece of coordination, an orchestra of living matter performing without pause, and though the individual notes may be fleeting, their combined melody is the essence of you. If you could stand outside yourself for a moment and listen, you might hear it. The faint electric murmur of life, each neuron firing, each heartbeat echoing, each breath sinking in perfect rhythm. It would sound not like chaos, but like the gentle hum of existence itself, steady and serene. Perhaps consciousness is nothing more and nothing less than the universe learning to hum along. The nervous system has carried you through every joy, every thought, every quiet pause you've ever known. It has guided you through danger, soothed you in calm, remembered what you loved, and helped you forget what you didn't. It's the foundation upon which everything else has been built, not separate from who you are, but the essence of it. So tonight, as you rest, you might take a moment to feel it, that subtle pulse beneath your skin, the soft rhythm of breath and heart, the faint tingling of aliveness that never truly stops. It is your oldest companion, your silent storyteller, the network that holds the spark of self. And as you drift towards sleep, that spark will not fade. It will continue to flicker quietly, watching over you, resetting circuits, preparing for another day of thought, movement, and wonder. It has been awake since before you were born, and tonight it lets you rest. As the night deepens and this quiet exploration comes to a close, it's worth pausing to marvel at the simple truth behind everything you've just discovered. All that you are, every sensation, every thought, every emotion, runs on tiny pulses of electricity. Within the stillness of the body, there is movement beyond measure. In every second, billions of signals travel through nerves and neurons, carrying the language of life itself. And somehow, out of this endless communication, consciousness arises, not as noise, but as harmony. The nervous system, so intricate and invisible, is what keeps the world in focus. It listens to the heartbeat, guides the breath, senses warmth and touch, and turns them into experience. It balances instinct with awareness, control with surrender. It works quietly, tirelessly, from before birth to the very last moment, making sure that everything within you remains in conversation, cell to cell, thought to feeling, dream to waking. It is humbling to realize that such staggering complexity depends on the simplest of processes: ions crossing membranes, currents flowing down axons, chemicals drifting across synapses. Nothing mystical, nothing mechanical, just energy moving in perfect rhythm. Yet from that rhythm comes everything: music, memory, laughter, love, curiosity. All the things that make existence beautiful are shaped by the same gentle forces that once animated the first living cell. Within every heartbeat and every breath, there is quiet coordination. The nervous system does not seek applause. It does not rest or demand attention. It hums on faithfully through sleep and waking, through stress and calm, orchestrating life without ever asking to be noticed. You blink, swallow, think, and dream, all because of this hidden conductor beneath your awareness. It's the great unspoken partnership between body and mind, between electricity and emotion. Think of everything that has unfolded on this journey, from the first neuron-forming connections in the womb, to the glowing highways of the spinal cord, to the brain's endless symphony of thought and memory. You've seen how the senses gather light and sound, how movement and emotion intertwine, how the gut and brain share quiet secrets, and how even in stillness the system renews itself through sleep. Each part is astonishing alone, yet together they form something even greater: the story of a living self. That story continues moment by moment, written in electrical sparks that flicker and fade, only to return again. It's a fragile magic, yet one that has endured for as long as life itself. When you think, when you rest, when you dream, the nervous system carries the flame forward, not for any grand reason, but simply because that's what life does. It continues. Science shows us the machinery, the neurons, the synapses, the pathways of the mind, but it also invites a kind of serenity. Knowing how the system works doesn't make it less wondrous, it makes it even more so. The fact that thought arises from the same physical rules that guide rivers and stars reminds us that we're not apart from the universe, but expressions of it. Every spark that lights up your brain is part of a larger current, the same one that flickers in lightning, in the aurora, in the sun. The more you understand the nervous system, the more it feels like an act of grace. You don't have to tell your heart to beat, your lungs to fill, or your neurons to fire. They already know. They've known since the beginning. Beneath every conscious act is a foundation of trust, the body knowing how to live without instruction. There's peace in that realization, a reminder that you are held by the same intelligence that sustains all living things. And so, after this long and gentle journey through the body's hidden network, it seems only right to slow down and let that knowledge settle. The nervous system that has kept you awake and alert through this exploration will soon help you rest. It will dim the lights of attention, soften thought into dream, and carry you from wakefulness into renewal, as it has done every night since you were born. Tonight your neurons will whisper to one another in sleep, replaying patterns of memory, repairing what's frayed, and strengthening what's important. Your heart will continue its rhythm, steady and sure. Your breath will find its quiet pace. Even in silence, your nervous system will hum on, ensuring that every cell feels the warmth of connection. So before you drift away, take a moment to thank this hidden companion, this luminous network that lets you move, feel, and dream. It has never stopped working for you. Not once. It is your first awareness, your last spark, and everything in between. Thank you for exploring slowly, for taking time to listen, to learn, and to wonder. The world inside you is every bit as vast and mysterious as the one beyond, and when you close your eyes tonight, that same quiet electricity will keep flowing, keeping the body safe, the mind at ease, and the story of you alive for another day. May your neurons rest easy, your dreams be bright, and your thoughts drift gently until morning.